Hello and welcome to the course on Learn API, REST, JSON, XML and Web Basics. Super excited to have you here for this course to teach you about web technologies and REST API concepts along with JSON and XML. This course focuses on learning the core concepts of API and REST. Also dive into essential data formats like JSON and XML with hands-on. And finally, you will learn core concepts of web technologies. This course focuses on learning both theory and practical. So from theory wise, you will learn theory on the core concepts of API and REST and web technologies. Then practical sessions will be with JSON and XML. Let's review what topics are covered in this course. Here are the 5 topics that you learn in this course: API, REST, JSON, XML and web basics. I have designed this course carefully so that it reaches a wide range of audience, and I have taken enough care not to use technical jargons or fancy words or unwanted examples. I have tried my best to keep the explanation simple, fun, interesting, and most importantly, focus on learning the concepts. This course is designed for students who want to know about API, REST, JSON, XML, and web basics. Students who want to learn web technologies can take this course. Also, web consultants, executive managers, business users, application consultant, project manager, developer, or tester who want to know more about these technologies can take this course. If you are new to all these concepts or eager to learn it from scratch in greater detail, then this course is for you. With 30 days money back policy, there is nothing much to lose as well. I also suggest you review the course description, key highlights and curriculum to better understand the topics covered in this course. Alright, thank you so much for your attention to listening till the last. I wish you a fantastic day. See you in the course. This section is about learning the terms like API, REST and REST API. This course is about learning the new trends and new emerging APIs in the market. We have seen web services and SOAP, and now the trend is REST API. Well, REST and API are two different things. If you are pretty new to this term and might be hearing for the first time in this course, then do not worry. I will make them very easy for you to understand by covering from basics, and I will touch base all the important points. In this section, I'll help you understand what is API, how it is different from web service. Then we'll look at REST definitions and how it came into existence and what is the purpose of it. Then I'll try to combine some terms together to understand how JSON is used in REST API and how it is used as a data interchange format. Finally, I'll show how tokens are used to access the REST API. Also, I'll show some API management tools that you can find in the market. Okay, so let's start the session by understanding what is API. So before understanding what is API, let me start with some basic terms. Terms like what is service. If you're looking at this diagram, you have right hand side you have a server, left hand side you have a client. So server generally hosts a service. A service is nothing but a function or a method that can be reused. So a server could host a service like add service, weather service, a validate XML service, and this service is basically a piece of code that has been written in Java or .NET and exposed in the server, right? And now client A or B, maybe your computer or maybe a laptop or maybe a mobile device, can make use of this service. They don't have to write everything, they just have to call this service and the service will execute the business logic and return the output from the service. So it's basically a reusable concept. If there's a service available in any of the server, you can just go and use it. So that's a term called service. It's just nothing but a function or a method that can be reused, and it's mostly available in a server. And next is, what is a web service? Well, web service is very simple to understand. A service that is accessed over a web is a web service. So any server that is hosting a service which is accessible in the internet, and then you can use some of the protocol to access that service, then basically that is a web service. Again, similarly, the service could be anything as per what the business logic has been defined in that service. But most important, the term web service is used when a service is accessible over the internet. Okay, so that's another term for you. And in terms of a web service, there's always this request and a response. So first, whenever the service is available in the server, it actually is just sitting there and waiting for a request. So every client that want to use the service, they raise a request. And as I told you, the web service use a protocol called SOAP protocol. Client will initiate a request to an server for that service by using the SOAP request, right? And then the data will be stored in an XML and that is passed over to the server. And once server receive that request from a client stating that okay, now the client want to use this service, the given data or basically an input parameter to that service will be passed over, and server execute that logic in the server and returns an output of that service, and then that output is basically sent back to the client, and then the client will receive that response and then hence close the connection. So this basically, in a web service, always understand there's a request and a response. The client initiates the request based on the XML, passing the data whatever required to call the service, then server will respond back with the output of the servers in the same XML format to the client. Well, there's another word called interface. So let me explain to you what's the difference between the service and an interface. So if you're looking at this example, let's say we have our iPhone, and iPhone has various interfaces, right? It has this feature of clock. You can access browser, you can access the mic to record, you can do start and stop, then you have a calendar function. Some of the interfaces are basically attached back to an hardware device, let's say clock or a mic. A mic is a good example, right? Mic has an interface between the hardware to the phone, and then if you want to build an app which uses the mic feature, the mic will expose an interface for you. An interface basically the way you communicate to that mic, and using that interface you communicate to the mic, and your app will capture all the details, and then in the background it uses this interface to to record or to get the data from the mic hardware device. So imagine, service is basically a function or a method. Web service is a piece of software, a piece of service written in an internet. Interface basically is a way to access something. If there is a mic hardware sitting in your phone, or basically a start and stop button in the iPhone, the interface will provide you a method to use that hardware device. The phone already predefined with set of interfaces for you to access each of this application. Let's say you want to change the time, you don't directly go and change the hardware settings, right? You don't have that low level API access. You directly go ahead and access the clock via the clock interface exposed by the phone. So that's how an interface will work it's different from the service, because interface will give you an access to that specific device or an application or basically an hardware. So let us now define what is an API. If you're hearing API for the first time and trying to understand it, then basically API is a concept, okay? Not a function library, not a programming language, or not a protocol, right? It's just a concept. So go from it. API is the way you do interfacing, okay? That's basically a concept. So here's the full form of an API. API stands for Application Programming Interface. There are 3 words in it that's really help you understand what is API. First is the application, second is the programming, third is the interface. We learn what is interface. Application is nothing but the component or the apps, right? Like mic is an application, right? And then programming means anyone who want to access that application via that interface, then it needs to use a program to access it. Okay, so let me repeat. An application exposes an interface, right? And then a programmer or developer will access that functionality of the device or an application via that interface. Okay, so let me elaborate with an example. Imagine right hand side is your application or server. Then you have all these APIs, or basically I will not use API, I'll say interface. Okay, like get system health API to access the system health, then get RAM status, get disk status, get date time status. So all these interfaces that's available for the application. So no one directly go and figure out what is the disk status of an application. If they want to know the health, they want to know the system health, they use this interface to understand what is this application is doing. So there is a set of interface defined, and once that interface is defined, you have no access to the application. And then that's basically the definition of an API. You expose your application with some set of APIs, with set of interfaces to say, in order to talk to me, right, you have only available interface. You have only this set of interfaces available to talk to me. It's like, setting up a standard ahead, saying if you want to talk to me, then you have, these options available to talk to me. Apart from that, we're not going to do or communicate with each other anything else. And then no one have access directly to the application. That's the benefit of the interface. It provides a layer on top of the application stating what it can access and how it's been going to respond when a request is made to these APIs. The program in the API stands for the program that is used to call these interfaces. Okay, so let me do a proper definition of an API. API defines what functionalities are available, how it can be used, and what format it will accept as input or return as an output. Okay, that's basically a very proper definition of an API. And if you don't understand what is it, it's very simple to view from the three words that I've just explained: application, interface, and the program. Application exposes interfaces to say, if you want to communicate with me, these are all the interfaces available to communicate with me, right? And each interface has a request and response, like the service that we have seen. Even interface have a request and a response. And then you want to talk to me, you talk to me via a program. So I will expose my interface in terms of an standard programming language, standard programming methods. Like, you have to send a JSON data to me, then I'll respond to a JSON data, something like that. But in terms of a standard point of view, my interfaces will be exposed as an programming standard. So any program can typically come and call that interface. Think API like, companies exposing it for every programmer to use. I'll give you a very simple definition. Let's say all your files are available in a Dropbox, and then you want to access Dropbox. Dropbox in the background is a server, is a big data center sitting somewhere in a location. He don't give you access to that server like a file system, right? You cannot just go to a Dropbox using an FileZilla, open a port FTP, and then download all the files. They expose an interface. They say, to access your files, these are the interfaces available. The interfaces is a generic term, as again I tell you. It could be a mobile app, it could be a web application, it could be an API, right? API generally means you need to talk to an API via a program. Interface is different, right? A mobile phone, a human can talk to that API, to that interface. An interface of web, a human can talk, but an API, only a program can talk to an API. So they expose their API via some programming language, via some programming standard, and then they use JSON or XML as a data standard to exchange the messages. So Dropbox has an API. I'm going to show you that in the later sessions. Dropbox has an API where you can connect with any programming language, and then you can request to download a file, request to create a folder. You can do all sorts of operation. It's again limited because Dropbox only provide a set of APIs for you to access your files. It does not provide direct access to your application. That's why API is basically an interfacing, and as P in API, that's a program, so it allows only a program to access that API. Even Google Map API expose functionality to access the map with limited APIs and defined format with input and output parameter. Even think of a printer. Today, those printers that we see, the big HP printers, or IBM based printers, Canon printers, they have an API attached to it. Means if you want to print from a program, you can use that API from a program to send the data to the printer, and the printer will print it. Even iPhone has an API. Even your iWatch have an API. Yeah, right. So API could be an interface via which we can access the application. It is defined and allowed limited access with some rules. That's basically the API. Next, let's look at what is REST. The full form of REST is representation, state, transfer. But what actually is REST? You need to understand that REST is a design pattern, not a protocol. Well, what's the difference? If you know what is a design pattern, then you might know what I'm talking about. Well, if you don't know what is difference between design pattern and a protocol, don't worry, I'm going to explain you that. So let me explain you what is a protocol. Take an example of a 3-pin plug, that only fits in a 3-pin switch. Well, that's a protocol that has been designed to work only one way. Means the way the adapter is built is only to fit inside into one of this specific specification. If you change the switch, that 3-pin plug won't work or won't fit. Means the protocol will not work. Well, design pattern is not like that. It is not a specific set of rules that has to be followed. Take an example of an house design. Well, house design is a guideline or a design pattern you can choose to follow. Well, design patterns are like guidelines or rules that you can choose to follow or not. You can follow some and still get the benefit of it. It's like you have a house plan, right? You can pick some of the design from the house plan and can still build the house. Well, rest is basically a design pattern, right? You can, like a house plan, right? You can choose to follow whatever the design that's available in the rest. And when your design follows the patterns that has been listed in the rest, then you call it as a rest. Let's understand further what is rest all about. Don't forget this one definition throughout the course, that rest is a design pattern and nothing. It's basically a concept that has been proposed by a professor. Well, REST is a design pattern to exchange message over the web. The professor named Roy Fielding written the thesis on what is the best way to exchange message between two systems over the web. Well, REST is just a design that Roy proposed in his papers, and it has 6 design patterns. Any communication over the web between two systems follows the 6 design pattern, then it is called as REST-based communication. I've given the link to this thesis. You can read it and understand how REST actually was first defined by Roy. The 6 design patterns, I'll give you simple and easy to remember definitions. The first one is a client server design pattern, which actually says the communication should happen in a client server environment. Second is stateless. The server should not store any state of the client like session or anything. So server doesn't know any state of a client. So every call the client makes to a server is a new and without any state that's been stored in the server. Third one is a cacheable. Client should hold the cache of the communication. And it's a layered system. Layered in the sense a client cannot ordinarily tell whether it's connected directly to the end server or to an intermediate along the way. So you might have a load balancer, you might have a distributed environment in the server. So client should just able to connect to any of the available servers that's in the architecture, and then it's layered in the system. So it need not to be directly connect to the end system. Code on demand. Basically, a server can pass over the executable code to the client like JavaScript to execute it. Uniform interface. This talks about how the message is packed and exchanged or identified from the server. Well, many REST services out there does not follow all the 6 design pattern that Roy has proposed. Well, some might follow some of the design pattern and still claim it to be REST. Remember, REST is a design pattern. You need not have to follow all the 6 rules, but you choose some of the very specific and important ones, and then you build your REST services around it. But there are some rules that you need to follow, or else it will not serve the purpose, right? So REST has some specific rules that I'll discuss in future lessons. But remember, REST is a design pattern proposed by Roy Fielding in one of his papers, and it basically have 6 design patterns. So let me give you a proper definition of REST. Right? REST stands for representation state transfer. It's a style of architecture based on set of 6 principles that we have seen that describes how network resources are defined and addressed. So let's say a client want to do some operation on the server's objects or resources, right? Then REST generally talks about how the messages is been sent over to server and how the communication should happen inside the web and what is the best way to do it, right? That's basically the architectural guideline that Roy has proposed, and that proposal is called as REST. Next, let's look what is REST JSON API. Well, REST, JSON and API are three topics that is combined together to represent something. We know what is REST, we know what is API, and we know what is REST API. We also covered JSON in a previous section. So REST JSON API is just a term to show that REST API is used to exchange message and the message format is JSON. There's nothing special about it. And there are three different topics combined together to show the representation of how the message is being exchanged from one system to another system. So if you have to really separate it out and look at from how a REST JSON API works, then API that actually uses the REST design pattern and exchange information using JSON, then it is called as REST JSON API. We can even transfer XML, but when due to lightweight communication, JSON is more preferred. You can even say REST XML API, but REST JSON API is more preferred because of the lightweight and faster communication. Where there are two concepts when we deal with tokens, or basically it is authentication and authorization. If you are not familiar with these terms, then let me help you understand it. Well, authentication and authorization are two different things. Authentication is basically used to get access to the REST API. You need to have a proper user ID and a password. And user ID and a password is like an authentication to connect. And an authorization is basically the kind of operation that is allowed to performed on the resource, which is managed by the authorization. Let's say you have access to an API, but you only give an authorization to execute get method. You cannot execute post, put and delete. That authorization you don't have for your user ID and user ID based on your authentication. Token is nothing but a key issued by a server to client with some permission. So let's say if you want to connect to an server, right, which is hosting a REST API, you first need to get an authentication, user ID and password. Once you get that, you need to have a token. The token generally have the authorization. Authorization depending on what type of operation that you can perform. And this token generally will be available with the client. And every time client makes a connection to the server, it has to take this token and go to the server, and every time it has to authenticate to say, see, this is my token number and I have the authorization to do this. Then server will verify the token, and based on the authorization, it will allow the type of operation you want to do. Remember that token is an authorization. Like you can only do get or post, and all the other operations are blocked, something like that. Client can use this token value and it passes it to the server every time it connects and prove it has authorization to access the resource. It is every time. I mean, every single connection, this token will be verified. This is basically an authorization. Right? Do you have an authorization to perform this operation? Let's say it is making calls from last 1 month, and today I just gave an one more operation type like post to that token. The next call that is being made, every time server checks, and the next call is made, it will check whether it has a post authorization, and if it's available, it allows that post connection. So it's almost a live connection and live authorization, and every time it checks, and there is no state is being saved to the server, because you remember the design pattern of REST, it says stateless. There's no state saved to the server. So every time client has to provide its authorization to the server to make sure the connection is valid. And token based REST API means having the authorization to access the resource using the token key. Token key is very simple, like an alphanumeric set of characters which has been shared from server to the client, and client uses it every time it makes a connection to the server. Very simple concept. So next, let's look at the API management tool. We know what is an API. API is a simple service that system can use to interact with each other. So if there's a car has an interface, right? Then if you have a printer has an interface, right? But API is different, right? API is basically a program has to interact with that application using the interface. So Dropbox, printer, iWatch, iPhone actually releases all these APIs, right? They are basically the mean to communicate with that application. Well, API management is a process of managing the API. Why you have to manage an API? Because you see, when so many APIs has been released by the application. It has to be managed to make sure the user or basically the program has the right authentication and authorization to access it. And then the deployment portion, how it is being deployed, what level of speed that needs required to connect and process the message, how you put a limit on the API to access it, right? These are some of the features, right? Let's say the features are easy to create and publish an API. It's very easy. Let's say you write a piece of code, you want to publish it as an API and automate the documentation process of how API to be used. Let's say when you write a web service, you have to have a WSDL file. So similarly, when you do an API, when you write a function, right, like an add function as an API, the API management tool automatically take care of documenting like what is inside that API. You don't have to document that. It automatically provide whatever the operations are available, what are the methods available, what is the URL. Like you see the Dropbox API just shown you previously is something like is automatically done by the API management tool. And self-service connection using token. So you don't have to create a connections or basically you have to create a token and share it with the client. The client himself go to that documentation library or the API library and then create a token for themselves. And ability to limit the number of calls to API. So in API, you can say how many calls can be made per hour, per minute, per second. All those can be managed so that it is not so client doesn't or a program doesn't bombard with thousands of messages. So there's a limit that you can restrict, and you can scale to any level. When it's a cloud-based API management tool, you can deploy these APIs into any of the region specific instances. You can just like a click of a button, you can decide what is your server size and basically where you want to deploy this API in which location. Okay, and then control access on how it is being used and how it is being deployed is completely managed by the API management tool. And analytics and reporting dashboard is basically one of the cool feature of API, because now from once you have this API in the cloud or basically with an API management tool, right, you get all these demographics saying that how many people are using it, from what time to what time they're using it, what is a peak load, what is a non-peak load, and all those details will be provided automatically by the API management tool. So you don't have to worry about all these things. Once you write the code, you use this management tools, you deploy the API there, and then the whole ecosystem will take care of the API management. A good example of API will be a weather API, a currency API, and a stock API. And the benefits, any device can connect using JSON data standard and REST protocol. So when you define an API, you can say to use JSON as a data standard, REST as a design pattern, but HTTP as a protocol. And lightweight communication, and it is basically a limited connections also. You can restrict that with the API management tool. And you can track everything and block everything. That's basically the power of API management tool. Okay, so here are the API management vendors. That's basically the top vendors who actually provides the API management tool. And then every tool has its own implementation standard, but mostly when you define an API using REST, you don't have to worry about which API management tool have to use, because the language you use to write is basically based on the REST protocol. That is basically the HTTP protocol. I know I say REST protocol, so don't be confused. REST is not a protocol, but when I say REST protocol, it's basically an HTTP protocol, because REST says to use HTTP, right? That's basically design pattern. The one that I like very much, I think I heard some good feedback from the Gartner and also from the industry, is basically MuleSoft, and I have seen some big customers also using it. I'm not just promoting it, but I have actually played around with MuleSoft and SAP, and I find SAP and MuleSoft typically are very good softwares. There are other softwares which I haven't tried, so I cannot comment on that. But if you want to get a trial version and start working with it, MuleSoft generally is very quick and easy to adopt. This section is about understanding. Before going into details of JSON, I would like to explain on how two systems can communicate with each other and what are the various options available today. Imagine scenario 1 where system A wants to communicate with system B. So let's say system A wants to send product information to system B. Then here are the various options that system A can follow. System A can pack the product information in a comma tab delimited file and then pass it over to system B. Or system A can use XML as well to send information to system B. XML today is basically most preferred, and as it is more readable and represent real-time scenario with markup language. Okay, so let me show scenario 2. Scenario 2, system A wants to save some data for future reference like configuration file or user settings. Then system A can use .ini files or .property files to save the configuration or the user settings of the system. Okay, so system store data or exchange data over the network with other systems, and we have seen different formats, like tab delimited, comma delimited, .ini, .property, and XML files. Well, all these are data formats which are human readable, and they are used mostly to do data interchange between two systems, or a system can store its state into this file system. Well, all these data formats are human readable data interchange format that can be used to exchange data or store the data. So remember that there are these different formats available to exchange the message. So let's understand what is JSON. JSON stands for JavaScript Object Notation. Well, that's the full form of the word JSON. And JSON is a lightweight, which means the size of the JSON is small. It's human readable, means once you see a JSON, pretty much you will try to able to read the JSON by yourself. And it is a data interchange format, means it is a data that is used to exchange between the two systems, like we have seen previously, like XML, tab delimiter, and CSV file. JSON is one more format that is used to exchange message between two systems. And the main purpose of JSON is to represent data and exchange that data over the network. But before we jump into details of JSON, let me show you a simple JSON file, and they'll walk you through the JSON file. Then let us understand whether how easy it is to read a JSON file. This is a sample JSON file, and this is how a JSON data is been represented, right? And without even describing what is this all about, I want to tell you that JSON is a human readable, we just look at the data and then you should able to predict how the data has been organized, right? The data is organized with some curly braces, and basically it is separated in a rows or separated with some column names, right? So but just looking at this data, you can identify what is all about. Well, this is all about product, right? It basically talking about some product descriptions here, right? I don't have to explain you what this is all about, but I just want to bring you the point that by just looking at the data, it's very easy in JSON to understand what the data is all about. And even just to walk you through of this JSON file, I want to show you that there's a product, there's a row, and then each row is basically one product. And then by looking at the name of it, the product is something to do with a phone. It's trying to describe a phone, give a price, give availability and different colors of the phone. But the point here is it's very much readable, right? It's not like XML where if this data has been represented in XML, it's basically a very big file. Then you have to scroll through up and down to figure out what is all about. But just looking at the JSON is really very simple and easy to understand format. So we learned JSON, and then we have seen a JSON sample data, and JSON actually means JavaScript Object Notation. But why the name JSON and why it is related to JavaScript? And one more thing I want to clear, that JSON and JavaScript has no relationship. Then why JSON is called as JavaScript? Before we go into the detail, I want to tell you that JavaScript is a web browser scripting language. It's a client-side web browser scripting language, and JSON is basically a data interchange format, or using JSON we represent the data, we save the data using JSON in the JSON format, and then we exchange the data over the network, and it has no relationship with JavaScript. So always remember this, JSON and JavaScript are not same. Okay, then you might be confused why JSON is named as JavaScript. Well, there's a concept in JavaScript called as JavaScript Object Literals, and this JavaScript Object Literals is similar to JSON format. So I'll show you an example what is this JavaScript Object Literal means. Basically, JavaScript object literals is nothing but the way objects are defined in JavaScript is similar to the JSON format. Means the structure that is used to define objects in JavaScript is a similar notation how JSON is being defined, right? That's why the name is being taken from JavaScript object literals, but JSON and JavaScript has no relationship. JavaScript is purely a client-side scripting language, and JSON is a data interchange format. So let me show you an example of how JavaScript object literal looks like. Where I have a separate section, we will write this code, we will execute this code, then I will walk you through what are the details of it. But the one that I've highlighted here is basically a HTML file, right? In the HTML file, there's a JavaScript section where you can write the client-side scripting, and in that scripting, I've highlighted how an object is being defined in JavaScript. So if you say var, that's a variable called product, then you define some variables in it, like product ID, some value, product name, some value, product price, some value. And then how you access it, you access it with the object name dot field name. It's like, you define a class and a member variables, and then you create an object of the class, and then you use a dot notation to access those variables. It's something similar concept, right? You have an object, then you use the class name to access the object's variable, right? This concept in JavaScript is called as JavaScript object literals, right? And this is the notation that you see here on the right hand side. The object notation, literal notation, is similar how the format is defined in JSON. That's why JSON is called as JavaScript object notation. It's the same notation how objects are defined in JavaScript, is the same notation how JSONs are defined. That's why the name came from. But there's a separate section. We will write this code, we will execute this code, and then we'll play around with it. There I'll give you more details about it. So let me summarize this introduction to JSON section. So what is JSON? JSON stands for JavaScript object notation, and JSON is a data format, right? Always remember this keyword. When someone asks you what is JSON, just give this answer. JSON is a data format, right? It's a data format like XML, it's a data format like CSV, like tab delimiter. This is one more data format. The main purpose of JSON is to exchange or store information. So you store the data in the JSON and then you exchange over the internet. So we have seen JSON examples. Basically it is very easy to read, and mostly it is human readable format, and any programming language can read JSON because there's no restriction in JSON that it should be read in a similar manner. Like in XML you use DOM parsers or SAC parsers to read the XMLs, where JSON doesn't have such kind of restrictions. Anybody can just use some libraries to read the JSON file. And the good news is that popular programming language like Java, .NET, Python, they already provide some predefined libraries in those native languages to read JSON files. So that basically shows how it is very popular in the programming language as well, and how it is very much adopted in this industry. And in JSON, everything you write is text based. There's nothing called inserting an image, inserting an attachment, no fancy stuff. It's very simple text based data that you basically write in JSON and then you exchange over to a system. Okay, that's basically about JSON. Next we will learn what is the difference between JSON versus XML. So let me do a comparison between a JSON file and an XML file and understand what is the difference. So this is a product.json that we have already seen, but I have not gone through all the details with you. But as it is a human readable format, I'll just walk you through what is this all about. So this is a product.json file representing some product, right? So you have a product tag and starting to represent to say these are all the product items. You have 3 rows in it, row 1, row 2, row 3. Row 1 indicate one product, row 2 indicate another product, row 3 indicate the third product. Each product have product ID, product name, the name of the product, description about the product, it has a price of the product, the availability of stock, then in what colors the product is available, right? So I'm taking an example of a phone, like 3 phones, iPhone, S8 and XS, right? And I've given some description of the phone and the price and the availability, let's say the stock availability, and then the colors I've used black, white and ash, black, blue and green, and then the one that I've indicated that I don't know the color because it might not be available in any other colors, or I don't know the data, I don't have a data to represent that colors, right? So I've set it as null, right? So this is basically a simple product information that I'm showing in 3 rows. Let's say if you want to represent the same data of product in XML, right? You define something like this. You will have a product, you will have row 1, row 2 and row 3. You see, I have to scroll down to see the whole data, wherein I have all the data here just in one shot. So what I want to compare is basically how you represent data between XML and the JSON, and both JSON and XML are data interchange format, right? And we are doing the same thing. We have row 1, row 2 and row 3, and then we have product ID, name, description, price, availability of the product, and basically different colors of the product, right? The null is represented something like this. We don't use a keyword called null, we just don't open the tags and then close it. Okay, this basically represents there's no data in the colors of this particular product. Okay, the main difference between these two files are basically the file size. So let me show you that. So these are the same files. If you look at the path, right, it's the same path. Okay, so this I'm showing you the two path of the JSON and XML. So this is the XML. XML is 800 bytes and JSON is 500 bytes. So it's almost a double size for XML. And the main reason that you have to see here is JSON is lightweight, right? The JSON size is lighter, so it's easy to communicate between systems. Let's say imagine a scenario, right? You have to send a data from a computer to your iWatch. An iWatch, being such a lightweight device, cannot handle huge size of volume of data. So if you use XML based communication like web service SOAP from your iWatch, typically it's gonna be very slow, right? Because the size of the XML will be the restriction there, and then you cannot get away with it because SOAP works with XML. But let's say you use a different technology like REST, or you do an HTTP, right? And then you want to change your structure from XML to JSON. You will see a immediate speed, because the size of the JSON will be half of the XML size. That's where the JSON has actually came into the market and become very, very popular because of this one serious condition. That's basically it's lightweight and it's win over the XML of size constraint. The other differences I'll show you and I'll talk about it. So this is the difference between JSON and XML. I'll go line by line. Okay, the first difference is JSON is a text based format, not a language, right? Basically XML is a markup language. Because it's a language, it has a lot of rules defined in it, whereas JSON is a very free form text based format. You can define whatever you want to define, but it has some syntax rules though, which I'm going to discuss in the next section. The second difference is JSON is free to define anything, right? JSON doesn't say you have to use something like this. Our opening tag name should end with same name of the opening tag, and then you should use the closing tag symbols, right? It doesn't have those kind of rules. It just have very simple, straightforward, like 5 rules or 7 rules, and then that's it. That's what's the rule about JSON. Where in XML there are lots of rules that you have to follow, and it's very strictly typed, right? JSON, as I shown you, it's smaller in size. XML is big in size due to basically of markups. And JSON is similar to JavaScript object literals. So when browser read JSON, it actually know JavaScript, so it know how to read JSON. Where in XML, the browser need to parse XML, right? So it's basically slow in processing compared to how JSON is read in the browser. And one difference though is JSON does not support namespace nor comments. You cannot even write comments in JSON. Where in XML, both are supported. You can write namespaces and then you can write comments. That's basically the difference between JSON and XML. But I want to leave you one good difference that you always want to know about JSON versus XML. JSON wins over XML over the size, and JSON is a lightweight data exchange between two systems compared to XML. But also remember, JSON can handle lightweight and simple structures. It can even do some complex stuff, but when it comes to a business process structures, like EDI or B2B, XML stand out because it has to be complex to differentiate all those complex segments and structures that a business needs. And if you look at the standards that's out there like Rosetta Net, EDI, those are not JSON based today. Those are not defined in JSON today, and they don't support JSON today. So if you want to convert into JSON, you don't have a supporting organization in the background who can support your data. So stick with XML when you want to do a B2B like EDI, Rosetta Net, because they have a standard and predefined pips for it and predefined structures and documentation around it. But if you want to exchange a simple text that from one system to other system, and go always with JSON, that's basically the future now. Okay, so let's understand how JSON got its name from JavaScript. This is an .html file. Okay, so you have this HTML tags, then you have this JavaScript section where you write the JavaScript. So let me tell you how JavaScript object literals are defined. Okay, so you define a product variable, right, which is of type object. Okay, the curly braces represent it's an object. Okay, then you define fields under it. You have a field names. 3 names are there: product ID, product name, and product price are basically the field name. Then you have values assigned to it. Okay, this is a string value, this is an integer value, and when you want to refer the field values of an object, then you refer the variable name dot product ID and a variable name and a product name and a variable within product price ID. Okay, so let's run this file and you should see all the values like 101, iPhone 8 and 1000 with separated by a dash. Okay, so this is the file. Okay, I will refresh this. So once you refresh, you can see that you're seeing this value 101, iPhone 8 and 1000. You're accessing the objects from JavaScript, and this is basically a client-side scripting using JavaScript. Okay, now if you have to define the JavaScript object literal in JSON, means the way you define the data in JSON is similar how you define an object in JavaScript literals. Okay, so let me define a new file. If I have to define the same thing, okay, I have to define within quotes. So let's say I say product ID 101, product name, iPhone 8, then product price. Okay, so this is how I define a JSON file, right? So if you see the notation and how JSON is defined, it is similar to how Java object literals are defined. That's why the name of JSON is called as JavaScript object notation. And remember that JavaScript and JSON purposes are entirely different. JavaScript is used for client scripting executed in the browser. JSON is used to store the data which is exchanged over the networks. Okay, so let's understand JSON syntax. Syntax generally will help you write a JSON. So when you write a JSON, you have to follow the 7 syntax rules. When you follow this, then your JSON is actually will be well formatted, right? You can think like these are 7 rules that are required to write a JSON depending on what data type you're writing, right? Let me go through one by one, then we'll simultaneously write the JSON. Okay, so first thing, before looking into syntax, I always use .json as a file name extension to to represent the file as in JSON file, like we use .xml. Okay, similarly we use .json, okay, to represent this is a JSON file. So the first rule is JSON data is written in curly braces. Okay, that's the first rule. So if you're writing anything, you have to open up this curly brace and close it. Okay, you cannot write data outside or on top, right? That will be an invalid JSON file. You have to write inside. Anything that you're writing should be inside a parent curly braces open and close. And you cannot have notations like semicolons, colons, or anything that's representing here or it's representing here. That will be an invalid JSON file. Okay, so remember, everything that you write is inside the curly braces. That's the first rule. The second is data is represented as a key value pair. So everything that you know to do a notation in JSON, you use a key value pair. Okay, so that's basically like an hash map, wherein you have a key, you have a value, something like that. You have a key, okay, then you have a value for it. Okay, that's how you write a data in JSON. You don't write like this and then you just don't write like this. Okay, that's an invalid JSON, right? Don't write like this outside the double quotes. Okay, and you cannot write like this. That will be an invalid. Always you write a key and then a value. Okay, that's the second rule. The key should be enclosed in a double quotes. So always the key should be in double quotes, or else it will an error. Key basically represents what value you're trying to refer, right? There are some conditions wherein you don't need double quotes. That's basically when you're defining an integer, right? You don't need double quotes. So that's why there's no rule on value. Okay, the rule is basically on the key. The key should be written within the double quotes, right? Then the key and value should be separated with a colon. Okay, you cannot say key is equal to 1000. That's an error. Key something and and start writing some text here, it will error because this is a string, right? You have to write a string in double quotes. Okay, so the right way to define is you need to have a key. Let's say you are defining a product ID, right? And then the value should be in, if you're defining a string, the value should be in the string. Let's say this is a number, so I'd say it's a number. Okay, so you have a key value pair always. You cannot define anything apart from a key value pair. Okay, that's the second rule. And then you have a double quotes for key and colon as a separator between key and a value. The comma is used to separate the data. That's the fifth rule. So you want to add one more key value pair, you use a comma as a separator. Okay, so you say name, then you can use iPhone, then you want to write another key value pair, you basically use colon, and then you can write another key value pair. Okay, so you say is available, you say no, it's not available, right? Then you can, if you want to write one more, you use this colon to write it. Okay, the square brackets are used to hold the arrays. Okay, so if you want to write an array, then basically you use square brackets, and you want to define one more key value pair, you need a comma. Okay, let's say we have colors, right? Colors of the phone. Again, this is a key, then semicolon to separate the keys, then you have an array. Array is represented with the square brackets, and inside the array you can define values. Okay, and then each value, I'm going to show you what is an array in the array section, but now try to concentrate on the syntax of an JSON. Okay, okay, that's an array, right? Then you can again semicolon, and then you can define whatever you want to define. Okay, then the curly braces are used to hold an object. Well, this is an object, right? That's why it's called as JavaScript object notation, right? It's already an object, but you want to define another object. You cannot just define object like this. That's a wrong notation, because what is the rule number? Rule number 2, you need to have a key value pair. So you need to have a key to define an object. So let's say the phone released in these countries, then you represent with an curly braces, right? Then you can define key value pair in an object notation, right? You can say India true, comma. I'm gonna go how to define objects under an object, an object inside an array, those kind of stuff. But now try to concentrate, right, how you define an object. Okay, so one thing that I'm doing here is whenever I'm ending something, I don't need to use a comma. Let's say this is the last key value pair in the object, I don't use it, right? And this is the last one, then I don't use a comma here. But if I define another one like price, then I need to define a comma here, right, indicating this is a key value pair, right? This is the key with double quotes, and then separating with a colon, this is the value, right? Now I'm defining another key value pair, and to the last one I don't need to say comma because this is the last one, right? It's okay to denote that. Okay, so this is how you define a JSON file, and that's basically the rules of a syntax, right? I'll go one more time very fast. The JSON data is written in curly braces. That's what we have seen. Everything you write inside is curly braces. Data is represented with a key value pair. Everything is a key and then a value. Everything is a key and value. Key should be enclosed with double quotes. You cannot have key name without double quotes, it will error out, right? A key value should be separated by colon, right? Everything that you separate is colon, so sometimes the colons are missing, so you will have some errors. The comma is used to separate the data, so you have two datas like product ID and name, then basically use comma, and then you don't have to indent it, right? You can just use same line is okay with it, right? But the main rules are you have to use a comma to separate the field names. Square brackets is used to hold arrays, right? This is an array. When you write anything inside a square brackets, it becomes an array. Anything that you write within the flower brackets become an object, right? And how we define an object, how we define array, how we define these integers and everything, we're going to see in the next section. Okay, so understand its 7 syntax and try to create your own JSON data using this syntax. Okay, so next let's look at JSON data types. So there are 6 data types that's available in JSON, which means anything that you write in JSON, that value that you write for a key should be of these 6 types. You cannot write anything apart from the 6 type. You cannot define your custom type and use it. You have to follow the 6 types to define it. So let me show you one by one what are these types. The first one is number. So I have used a simple file with .json extension. You can even do this to start writing a JSON, and then I'll use some of the syntaxes that I've shown you previously, and I'll try to repeat it here with the syntax, and then we'll try to write a simple JSON file using all this using all these data types. Okay, so the first syntax rule is you open a curly brace and close a curly brace, and then you basically define a key. So let's say I'm defining a number, right? And the intention of writing this is basically, we want to define a product by using all the data type that's available in the JSON. Okay, So let's say I'm defining a product ID with a key within double quotes, and then I'm separating the value with a semicolon, and this time I'm defining a number, so I will use a number. Okay, now you can use colon to separate a new key pair value. Okay, next is a string. String is simple, right? So you can say a name, product name, right? And then you use double quotes to represent a string. Then I use comma to separate another line or another key pair value. Okay, next define a boolean. So this time the key pair value, if you're defining a boolean, don't make this mistake, right? Don't say is available like this and say true, right? Even though left hand side is okay to write data without the double quotes, but on the key you need to have double quotes. Okay, and then true or false is basically a boolean value that you can use. That string true or false false, you can use it as a text without double quotes. Then you use comma. Okay, next is null, right? Then you define, let's say, a model, colon, and I don't know what is a model, so I say null. I don't know the value. It means an empty tag or empty field value. Next is an array. Okay, we know array we define with a square brackets, so you can say colors of the phone, use semicolon, then you can define the colors. Okay, next is the objects, right? So how you define an object? You need to have a key value pair, right? So key is a name, colon, then you have an object like key and an array. You have a key, then you have a semicolon and an array. Similarly, you have a key, semicolon, and something with a flower brackets, right? So define a comma here, then let's say released in, right? So I say Singapore, I can say true, that's boolean. True, false. Okay, so this is basically an object notation, right? This is one data type, object data type. This is another array data type. This is a keyword null to represent no value. True is true or false. Okay, you can even write false as we have written false here down, right? To represent boolean value, anything that you write in double quotes is a string value. Number is represented with a number. And one more thing you can do is you can use decimal points also. Okay, so even decimal points are called as numbers. So it's very simple to work around with JSON, and these are the 6 data types that you use in JSON. So let me show you what are JSON arrays. We learned how array looks like. We also have seen the syntax of an array. Well, array is represented within these square brackets. So let me show you how an array of string looks like array of integers look like, array of array look likes, and array of objects. Okay, we're going to define all those things here. So the first thing, I have used a file and saved it with .json extension. Then I'll use a curly braces to write anything, all the JSON inside is curly braces. So let's first define an array of strings, right? So the first thing is, let's say you're defining a weeks, right? Then you have to give a field name. Then the value could be multiple value because it's an array. You open with a square brackets, and then you're defining a string. Then each string will be in a double quotes, and then you give a comma notation to separate your data, right? And if you are defining the values, the last value that you're defining, you don't need to specify comma here, indicating this is the last one and you don't need comma. But if you're defining anything apart from the first key value pair, you still need a comma in the last, and then you can start defining the other values. So let's define the weeks first. I'm gonna copy paste here. Okay, so imagine you're defining a weeks, right? I'm just saving time by copy pasting here, but you fairly understand the concept how you define the array of strings. Let's define an array of integers. Okay, so let's say you want to specify the days of a Sundays. Okay, for a specific month you want to specify all the dates in terms of integers in an array, right? Let's say you say the 7th is a Sunday, then all the following multiples of 7 will be Sundays, right? So 7, 14, 21, 28 are Sundays, right? And then you're defining using an integer, right? You're using an integer to create an array of integers. Okay, and you can use comma notation. Okay, so let's define an array of array. Okay, let's say you want to define Saturday and Sunday, so you want 2 values per week, right? So you define the key. The way you define is you have an array, right? You define another array inside an array. Okay, that's basically an array of array. Okay, so you have an array, you have one more array and 3 arrays in it with separated by comma, and then you define whatever values you want to define. Let's say you want to define like 6 and 5, 6 comma 7, not 5, sorry, 6 comma 7, 13 comma 14, 20 comma 21. So this is a notation how you define an array within an array, and each array is separated with a comma, and each value within an array is separated with a comma. Okay, so you have to identify how you write an array, right? This is how you write an array, and you want to write one more array in it. You use an array notation here, a comma notation to denote that I'm going to use another array, and then close off this array. That's how you write array inside an array. Okay, so let's define an object inside an array. So if you are defining another key value pair, end this with comma. Okay, I want to say define holidays, right, within that month. So I'm defining an array, right? I'm using the square brackets. Now I want to define an object. So I have 2 objects in an array. Okay, so you denote an object with curly braces. Okay, and within an object you define key value pair again, right? So you can say day is 1 and event is, let's say, liberty. Okay, then you are separating out with a comma, so you can start defining another object, say day, let's say 10th, event exactly. Okay, now you don't have to specify comma here because this is the last element or last key value pair in the array, and then you don't even have to close the array within comma because this is the last key value pair in the whole JSON file, in the last entry. Okay, so this is how simple you can define and work with arrays. So the first simple example is an array of string, second is an array of integer, third is basically an array of array, and the fourth one is array of objects. So let me show you how do you write objects in the JSON. Okay, so we have seen arrays, right? Now we will see object. The object, we will see a basic object, like how you define an object, and then we will see an array inside an object. Okay, so the first thing, when you define an object, you need to have a key, right? An object that is defined in JSON doesn't have a key, right? But anything that you define inside the JSON, inside the curly braces, basically you need a key for it. Okay, so let's say you are defining a product details, right? This is a key, right? And the value of a key is an object, right? You cannot define like this, it will be error, because anything that you define inside the curly braces must be a key value pair. Key should have double quotes and separate a value with a colon. That's basically syntax of JSON, right? So this is how you need to represent an object, and inside the object you actually write a key value pair. Okay, so I will define an integer first, then some name, then some price with decimal indication, let's say 0.67, right? Then I'll use the boolean value. Okay, and this is basically an object with the name, key name is product detail. So product detail value is an object. That's how you read it. Okay, now let's define an array within an object. So you close this with comma, then you define another key value pair, and this time we define an array. Okay, so we say colors, then you define, so you're defining an array with square brackets. Okay, it's as simple as it. You don't need to put semicolon, sorry, you don't need to put comma here because there's a last entry. Even you don't have to put comma here because there's a last entry in the key value pair. Okay, so this is how you write an object, and then you write an array within an object. Okay, so we have seen JSON syntax and JSON data types. I would like to show you some online editor tools that's basically very handy tools that you can use to work around with JSON. The first tool is called as JSON lint. This tool is basically used to format the JSON. Okay, so in the previous example we actually saw this JSON, right, which actually talks about a date timestamp, but you see the format is not so readable, right? So if you want to make it readable, you actually copy this data, you use a online tool called JSON lint, you paste it, and then you can actually validate with the syntax that I just shown you, or it basically do a pretty print, or it format the JSON file in a nice readable format. Okay, now it's very much readable. So that's one tool pretty much I use almost whenever I work with JSON to format my JSON. Okay, and then it also tell you whether the JSON is valid or invalid, right? And very simple, you just remove some of the rules that you have learned, and then you will know whether it's format or not, or it's valid or not, right? The next tool is called as JSON editor online. This basically represent the data types that we have seen just now, and then it show you in a nice object structure. Okay, let me show you that. So we have seen this JSON data type using the integers, string, boolean values, some null, and then array, and then object. Let's use this, and then when you copy and paste in a tool called JSON editor online, right, it will tell you everything that you have defined in what manner. Let me show you that. So if you copy paste here and say click on this arrow button, then it will show you, this is basically an array of 2 and this is basically an object of 3, right? And you look at how it's representing a boolean value with a tick mark. So it's very easy to understand what these values are all about when you work with this kind of objects. The number here actually represents the number of items, right? You can, if you make it true, you make it true, then you make it update it, it becomes true and true here and then true here. So you can play around with it, right? Very nice tool. One is JSON editor online to play around with the data and see if you have complex structures like you have arrays, object of arrays and all those kind of things. This tool very much help you. But if you want to, when you see some data like this and you want to format this data, use a software or use an online tool called JSON lint. Just copy paste here, or you can validate the JSON, or basically you can format the JSON from here. So let me show you how do you read an online JSON file with whatever data types, syntax, and the notations that we have seen. The first thing I want to show you, this is basically an JSON lint online tool used to format the JSON. Then JSON editor is used to understand the structure of the JSON. Okay, so let's take an example of the date timestamp, and then it's already available here, but we'll try to use this tool again. So let's read this. Okay, we know this is a key, this is an integer, then you have a separate with a comma, then this is a key with a string value, right? And then this is a string value, this is a string value here. Okay, we haven't given comma because it's the last key value pair, and this is simple structure, simple JSON structure. Okay, let me take a complex one which has arrays in it. Okay, so let's read this. We can even put it here and straightforward read it, but it's interesting to read here with whatever we have learned. Okay, so the coord is basically an object, right? It's an object with 2 key value pair. Whether is an array of object. It's an array and having an object in it. Okay, base has a station as a string value. Main is an object, main value is an object, and temperature has a value of numbers. Okay, yeah, and then all the other fields or the other values are basically an object. So you have a field name, key name, and then you have an object as a value. Let's read another one. It's simple, straightforward here, right? You have a key and then you have a value, right? Simple, straightforward. Okay, that's how you read the data in the JSON. I want to show you a real-time example. So this is basically an openweathermap.org, which provides an API. You can buy it from here to know, let's say you are writing an weather app, and then you want to pull the data from various sources. This site will provide you up-to-date information about the weather. Okay, so let's understand how they represent the JSON. Okay, so I'm opening up one of the JSON file. Okay, and yeah, so if you have a JSON file, you can copy it over. Let's say you find it from any of the site. You can use an editor first to see what's this all about. Okay, without even opening it, curly braces are objects, square brackets are arrays, and then what are the fields available, what are the keys available in it, and what are the values. Is a station basically, you see it's basically a string, this is basically a number, from the way that is been written here. Okay, so that's how you read an JSON file from an online. Wherever you see a JSON sample, you try to open it up, go to this tool and try to open it up and see how it looks like, and try to understand it, because it's mostly a readable format. And I want to show you one more site. Okay, I don't want to go into the details of it, but I want to show you this. Let's say you are going to do an API, right? That's basically a next section, what is API and REST API, if you don't know. But imagine this guy has exposed some of the services and you want to consume it. The way how they mention it, they say JSON and XML, because JSON is a data interchange format. XML also is an interchange format, but the difference that you find is when you pull JSON, this file size will be bigger. When you pull XML, the file size will be bigger, JSON will be lightweight, right? But how they define it, right? You want to call weather API or geo developer API, you have these two output formats. You can call it via JSON, you can get the data via JSON, you can get the data via XML. So that's how you exchange messages from your system to API XU system using JSON format. So if you go in the details, how is the API and how it's look like, right, you will find that they are using JSON format and then they are also using the XML format in it. So if you have followed through along the course, I want you to do this exercise. Okay, so I'll list out what you need to do in this exercise. First, you create a JSON file with extension .json, right, and you define one student information with the field names as key names as ID, name, class, age, and isNRI field. Definitely isNRI is a boolean field, right, and name and class is a string and ID as integer. Once you have defined this with whatever data that you can think of, then you can add an addressed object to a student as an object with fields like address 1, address 2, city, country, pin code. So address is basically the key name which has an object of different values in it. In that you can define pin code as integer and all other fields as string. Okay, add a phone number as an array to phone field with 3 phone numbers as integers. So you have a phone number key and the value is an array with 3 different numbers in it. Then you can add paid fee field and make the value as null. Okay, then you define an array of object to student and array of arrays to student just to show some values in it. Then you create student.xml similar to whatever notation that you have used, and then you define similarly the XML file. Then you compare the file size of XML and JSON. Okay, that's your exercise. Once you have done this, you can email me at support@pocast.com indicating the course name, and then I will verify it and I'll let you know the results of it. Okay, so that's it for this section. So next section we'll look at REST API. Let's look at the topics. The topics that I will cover in this section are what is XML and how it is used, understand the terminology, how to read this language. Actually, it is similar to learning a new language like Spanish. So I'll introduce you to a new lingo, which is XML lingo. How XMLs are structured and what are the standards. Then we deep dive into XML namespace and XML tree with live examples. Finally, we will create an XML file, then we will view it in the Chrome. Then I'll show you how to check if the XML is well formatted, valid and invalid XML. I believe always that XML basics should be very strong, so that when you learn another new language similar to XML, you should grasp them faster. So let's learn and start building our own XML files. First, let's look at what XML stands for. X, M and L. Then we will go into details of it. The XML stands for Extensible Markup Language. X in XML is extensible, which means extend your notion. Whatever idea that you have about the content, you can extend it. M means markup. Define your own markup. I'm going to show you what is a markup. L means language. So it's a language, so you have to follow the rules and create your own document. Let me go back again and redefine it. So X in the XML is extensible, means you can define language in the terms of whatever content you have in the mind. If you think of a student, then you can extend the language using the student first name, last name. If you think of a product, then you can extend the language using a product name and a product description, or whatever relevant to student or a product. It is up to you to decide how to extend the language. Everything you define in XML is made up of markup, and markup is a syntax of the language. A simple markup is something like this. You have an less than symbol, then the markup, then the closing tag, that's the greater than symbol, then some text, then a close-up of a markup. Right? So understand, everything that you write in XML, you write in this way. You don't write anything outside this one. So everything you define using a markup. So you write your own markups. The markup word that I have used, it can be defined as a last name, first name in context of student, a product name, a product description in terms if you're defining a product. L generally stands for language, which means it has a predefined rules that you have to follow. As I mentioned, everything has to be a markup. If you're writing outside it, then the language is not going to accept it. I hope the definition that I have shared is the easiest to remember. Never forget this picture, where also never forget what XML stands for, extensible markup language. That's why I have highlighted X in the extensible, M in the markup, and L in the language, just to show it's a full form of XML. Next, let's look at where it is used. Let's look at this picture. This picture actually talks about the purpose of XML. Let's imagine A on the left side and B on the right side are two physical systems. So A and B are two physical systems, and they both want to communicate. So they want to exchange some data to communicate. Like how we both are communicating in English language, similarly system A and B wants to communicate. Then in order for A and B to communicate, system A stores the data in XML format and then transferred over to system B. As system B is aware that system A is going to send the data in XML, it actually opens the XML document and read it and then understands it. Similarly, system B can pass over the different data using same XML format, and then system A actually understands what system B has sent over. This is how system A and system B can communicate with a common language, that is an XML language. Remember the main purpose of XML. XML is actually used to represent data and store it so that it can be referred later. I repeat, remember this definition. XML is to represent data. One more usage of XML is that many software applications heavily depend today on XML to save the data as a storage mechanism. You can even think it as a text file or a Word document which actually saves the data, or imagine XML as a container which holds the cookies. But really, XML is to represent the data. The only difference is that XML is a language based. So you need to follow some guidelines to save the data. As I discussed previously, you have to save the data in a markup language. The markups generally are used to represent the data that we store in the XML. So XML looks like something to do with storing of data and describing the data. Let's continue further. So let me clarify more about XML versus HTML. Did you heard of a HTML before? If not, then HTML actually used to write the web pages. Did you anytime try the source code behind the web pages that you browse every day? Well, that is written in HTML. HTML and XML are both markup language. That's a confusion, right? Because when you see how HTML is written, it's written using markup language. Even XML are written using markup language. So the confusion. But what is the difference between the both? Well, it's very simple. XML was designed to describe the data, and it focuses on what data is, whereas HTML was designed to display the data and to focus on how data looks. So remember this simple definition whenever you want to differentiate between XML and HTML. XML is used to describe the data, wherein HTML is used to display the data. As I told previously, web pages are developed using HTML, which are displayed on the browser, but XML is used in the backend to read the data and process it. So let me summarize what we learned till here. So here is a summary of what we have discussed previously. First is the definition of XML. XML stands for Extensible Markup Language. And then we looked at difference between XML and HTML. XML and HTML both are markup language, but they are not same. XML is used to describe the data, wherein HTML is to display the data. HTML has predefined rules, and XML we must define the rules. I use the word called tags. So in the next section we're going to look at what tags are. The XML main purpose is to store and transport the data. Well, that's all about XML. Simple to remember, right? Let's learn some new words in the XML language. Let me introduce three different terms that we use in XML. The first term is tag, second is element, and then is attribute. Let's look into each of it and understand where do we use it. The first keyword is tag. So when I say tag, I actually means some kind of text between less than and a greater than symbol. If you remember previously, we discussed about markup. Markup is a way we write XML. Everything in XML we write using markup. So now when we say tag, tag is similar to markup, right? So here onwards I'm just gonna say tag. I'm not gonna use markup as a term. A tag basically is a text which is between less than and greater than, and there are two different tags. First is that says there is a starting tag and there is an ending tag. So when you define a tag, you can choose any name inside it. As I said previously, if you're using for a student, you can use a last name, first name as a tag name, and if it's a product, you can use product name and a course description as a tag name. So here I'm showing you a starting tag and an ending tag. The starting tag, as I previously mentioned, it doesn't have a forward slash. It's the starting of a tag, then followed by some text, and then you end a starting tag with an ending tag. That's basically your language, right? That's basically a rule. Next, we talk about what is an element. An element is a starting tag, ending tag, and anything in between. So when you want to say name is an element, you're actually referring to name as a starting tag, some text, and name as an ending tag. So next time when I'm referring to element, actually I'm referring to the starting tag, text, and ending tag. Next is an attribute. Generally, attribute is basically an additional parameters for the tag. It just enhances the behavior or explain the additional meaning of the tag. And an attribute is represented with a name and a value. Let's take an example. Let's say you have an element course and it has a starting course tag and an ending course tag, and level is equal to beginner is basically an attribute. So you can say level is an attribute for a course and the level value is beginner. So the course attribute level has a value called beginner. That's how you actually define it. So let me recap and use all the terms that we have used. So I'm showing you an sample XML. Let's try to define with the terms that we have used. The name has a starting tag and an ending tag, and POcast is the data for the name. The course is an element, or course has a starting tag and course has an ending tag. Level is an attribute for course, and level has a value called beginner, which we can also say course has a level attribute with a value of beginner, and course has a value called introduction to XML. So that's how you actually define the whole XML. That's how you read the XML. Now let's look at how we structure the XML. Let's look at the structure of the XML. So let's start with the basics. Let's say when you open an XML, the first line that you should see in the XML is basically the XML declaration, which is mandatory for all the XMLs. So when you're writing an XML document, this is the line, like as I shown here, less than symbol, question mark XML version with a question mark and ending with a greater than symbol. That should be the first line in the XML document. If you're not writing this line and then trying to directly write the tags, then the XML will error out, because that's the language specifications that you have to start with an XML notation. There are two different versions to it, right? First one is just the version as an attribute. The second one, you have an encoding as an attribute. And if you don't know what is an attribute, just refer back to the previous lessons. So let me walk you through what is this version and encoding talks about. Version is not the version management of your document. The version basically say, as an XML, the specifications that has been written with XML is that version. It's not the version of the document. The encoding basically talks about the character set that is being used inside the XML. Let's say if you're writing a Japanese character, then you have to use a Japanese character set. The encoding set, you have to change it to a Japanese encoding so that XML actually, when it renders the output or when someone wants to read it, they know what's the character set being used inside the XML. Okay, let's go and create one document using this notation. Let me give you an example of what we're going to define inside an XML. Think of an example of product listing. Let's say we want to define an XML for a product listing. The hierarchy that I'm showing you now is basically a product listing which has multiple products in it, and each product has multiple fields in it. So consider one product have name, description and price, and then we have multiple products in a product listing. So let me give you some new terminology here. Product listing is basically called as root element or a parent element, and product inside the product listing is called as child element. You can also call it as child of the parent or child of the root element. When a child has another child, like name, description and price are the child of product, the product generally becomes the parent for name, description and price. So it's a hierarchy wherein when you want to refer to a particular node, you actually see whether you have child nodes in it or have a parent node to it. So let's try to display this product listing and with a product with name in an XML file. Okay, so let's start mapping the fields that we have defined and with the data that we have. So left hand side you actually see the tags and tag names. The right hand side you see the data. So now if you really get this, so you're actually defining a fields on the left hand side and you are mapping out with the data. Let's take Microsoft Office as a product listing as an example. And inside Microsoft Office, you have different products like Microsoft Word and Microsoft Excel. Microsoft Words can have different properties like name, description and price. The name could be Word, the description would be word processing, and the price is some $99. So let's build an XML with these two things. One is the structure, which is a field name, and then the data inside that structure. Okay, let's start building a simple XML using the definition that I've shared previously. So let's try to show the product listing with a product and with its fields inside an XML file. So I'm going to generate the XML, then I'm going to show it in the Chrome browser. So first, let's understand how to write an XML. The first thing that you have to do is when you create an XML, let's say I'm trying to create an XML, right? The extension should be .xml. So let's say I create a product file. You can say it as a XML, right? So when you change file name to .xml means when you display this file in the Chrome actually understands it to be an XML and it renders it to an XML format. Next up, I'm going to open this file and start writing the XML code. So first up, we're going to say this is an XML with version 1.0. So one thing to remember that everything that you define in XML should start with this notation. Then we're going to define the product listing as we saw, and we can close the product listing. So this could be a parent tag, right? Then we're going to define a child tag to the product listing tag. So you can see here the product is a child of product listing and product listing is a root node or a parent node. Now we can define the product with its child fields. The first field is name, so we can say it is Word. The second field is description. The third is price. And you can Once you save this file, you can double click this file to open, or you open the Chrome, right, and then you drag and drop this file. Okay, so if I have to run through this, what happened here? So Chrome actually used this extension to identify, or Chrome has already used this notation to identify this is an XML file, and then we try to render the output. Actually it knows which one is a parent and which one is a child. So this is a root node, then it has a child node of product, and the product has a fields called name, description and price. I hope that is a simple example of how to create an XML file. So I have walked you through an idea of how to define the notation that you have for a product listing and how to map it with the data, and then finally I have run through how to create the file and map out all those details together into an XML file. Hope now you can build your own XML files. So this diagram is similar to what we have learned previously about how to create the XML. It's just that to the parent node and to the child node I have added an attribute called title. As we learned about attribute generally provides an additional information about a tag. Now by adding the title to a product listing, we know what the product we're talking about. So product listing has a title of Microsoft Office, and then the product title actually have a Microsoft Word. So we know the product listing is about Microsoft Office and the product is about Microsoft Word. So when you have two products, now you can differentiate with the title. So that's the benefit of attribute. So attribute generally are small parameters or a property to a tag or to an element that you can define to differentiate between multiple repetitions of the product. So next up, we're going to learn about namespaces. So namespaces are generally used within XML document. And in terms, if you try to understand what is namespace in a programming language, namespaces are similar to folders. If you know bit background of Java or .NET, you defined packages in Java and then you define namespace in .NET. And it is when you come to the Windows, namespace are nothing but a folder. It's just a different container to say this is a container of namespace and I'm going to differentiate with a unique name to it, like a folder name. So let me give you an example of how we use namespace. So on the top, you have three different products. The first product have the same fields with the second product and the third product. The only differentiating between the three products are basically the data. If you look at the data here, you have the product and title, which is the same, and then there are different parameters to it. The first product has a color, the second product has a version, and the third product has a pages, but they are all three same products. And below you can see the complete listing of the XML document. The only thing is differentiation between the three different products is the first product is about clothes, the second product is about software, and the third product is about the books. Now the challenge is when you try to iterate or you try to want to get a value for a t-shirt or want to get a title, the problem that you're going to get when you try to read the property of a product. Let's say you want to read a property title for product of clothes, or you want to read a title for a product of software. Let's say you want to read the similar title for specific for books within the product. How you're gonna address it? Because they all have the same name, same hierarchy and same parent. So that's where the namespace comes in. The namespace generally help you to identify uniquely each of this element. So you put them in a different namespace, means you define it as a different name and then you achieve it by accessing that name. Here's example I'm showing with the namespace. So there are two XML documents here. The left side is example without the namespace and the right hand side is an example with namespace. So let's say you have three different products. First product is about clothes, second is about software, and the third is about books. Now you want to access softwares, right, like Microsoft Office with the same product and title. So how you actually achieve that? So let me walk you through how you can actually define a namespace for a given XML and how you can differentiate those same names within the same XML. So there is an attribute called XML NS. NS stands for namespace. And with an XML NS colon, you can define any character there. You can define any name there. It's not a rule to have a constant there. The only rule is you have to define with an XML NS colon. And then you can give any URL there. That URL is again a custom build. You can give whatever URL you want to. So I have defined here 3 different URLs because I have 3 different categories. So with XML NS colon C, the C I'm representing is to as a clothes, and XML NS colon S I'm representing as tools, right, or softwares. The B, again the next one, I'm representing with books. So if I have to write down the products below, I actually use this namespace to differentiate between each of the product category. If I use a C category, C colon product, then I'm saying this is a category for clothes. And when I want to access clothes, I will refer C colon products, which will help me identify the products inside the category. And similarly, I can use the same notation to access software and access the books. So it's very clear that XML namespace provide a method to avoid element name conflicts. And this is a very important topic in XML. So if you don't understand this, I recommend you to go back, read it and try to understand what's the concept behind it. It's very simple to understand. Next up, we're going to see when you write an XML, is it well formatted or it has any errors? Is it valid or an invalid XML? So first we're going to look how to format the XML. Means not formatting in the sense aligning the XML, but to check whether XML is well formatted. Because we understood that XML is predefined language, means it follows some kind of specifications and it has some rules, then we have to identify whether our XML that we have defined has others to that rules or not. So it's actually called as well formatted. So any XML that you write, you can actually use some online tools, or you can just view it in a browser to see whether the XML is well formatted or not. So I'm using an online tool called www.utilities-online.info/XST validation. I'm going to talk about what is XST, but use this tool to check what is XML well formatted first. So I've pasted an XML file there in the XML box, and then when I click on check XML well formatted, it actually validates whether the XML is well formatted. Now everything is okay, so it says XML is well formatted. But imagine I change up something. Let's say name, I have changed the case, and now when I check for well formatted, because XML is case sensitive, so you cannot have different cases from starting to ending tag or anywhere in the tags or the elements. So you need to follow that. That's basically to say that XML is formatted or not. You can even play around with this. Let's say when you're writing this XML, you have forgot to write the ending tag. So what's going to happen? Because this kind of errors are very common errors. So when you define an XML, you generally open this kind of tools, and before publishing those XMLs, you copy it over here and then you check whether it is well formatted or not. So let me do a check here. So here it's saying the price has never been closed. This is a cool feature, right? Yeah. So whenever you write an XML, make sure it is well formatted and it has been tested with any of the online tools, or you can directly open a browser to see whether the XML is well formatted or not. Okay, we have seen what is XML well formatted. Now let's look into what is a valid and an invalid XML. When you write an XML, right, you can actually predefine some set of rules to say, which is a custom rules, right? The formatted, we understood that you're checking against the XML's rules, like missing tags, case sensitive. How about defining a custom rules on top of the existing rules and then validating the XML based on those rules? And when those rules are not met, you want to say that XML document is an invalid document. So I want to bring you a new concept called XSD, which is XML schema definition, which is a recommendation that specifies how to formally describe the element in an extensible markup language. It's an XML document. So it defines the rules on how the data should be displayed and how many times the fields has to be iterated inside the structure. The example that I'm showing you on the left hand side basically is an XSD document. I'm not going to go through everything inside the XSD. I'm going to start explaining it because there is a section completely on XSD and UDDI where I'm going to show you what is XSD, what's definition of it, how to write it, what is the structure and all those things. But here I just want to bring you a point that you can define a custom definition and then you can validate those custom definition against XML to say whether the XML is valid or invalid. So I have defined a XSD, you can think as a rules file called as product.xsd, and then I have the XML file which defines the XML, and in the rules file I have said that the price has to be integer. Whenever you write an XML document and you want to validate those XML based on the custom rules that you have defined, you can match up whether that price field is integer or not. If that price field does not match with the custom rule, then XML is not validated and XML is invalid. So when the rules that has been defined is being validated against the XML document and XML document does not follow that rule, then we call that XML document as an invalid document. So let me show you a live example of how it is validated and invalidated. Now let's look at the example of how do you validate the XML against an XSD. I'm again going to the same site wherein I have pasted the XML document on the left hand side and the XSD document on the right hand side. So as of now, if you don't understand what is XSD is a rules file. You define rules inside on how the data and the structure should be defined inside the XML. There are a couple of things that we need to check. The first is you check whether XML is well formatted, right? This is what we learned in previous lesson. You can even check whether the XSD is validated. It is similar to well formatted. The second thing, there's another option where you can check whether XML is validated against the XSD. If you just quite run through it, you will know that I have defined an element of price of type integer. I have said that the price field should be of type integer. But what I have done is I have not defined the price as integer, and actually I have defined it as a string. So when I want to validate this XML against this XSD, I should get some error saying that this price does not follow the rule that you have defined. Okay, let's look up what's the result say so. Okay, so the results say the same thing. This $99 is not valid for integer and element price is not valid. So you can do two things here. You can change the price here to say to represent integer, or you can change the data type in the XSD to say it's a string, and it could be a price string or it could be a integer string, right? So let's take the first approach. Let's try to change this and see what's going to happen. Let's say I'm going to push back 99 as an price, and I'm again validating it. This time it is well formatted and valid. So well formatted, as I explained, is a structure. XSD validation is a structure. Then you can validate an XML against an XSD, which is nothing but validating the rules against your XML. By now you should have pretty much a good idea about XML, how to define an XML and how the XML language has been defined with different elements, tags and attributes. So we have seen a couple of things in this podcast. I just want to summarize this. First, we have looked at what is XML. We have defined what XML definition is, and then we have defined element, attribute and tag. Then we have looked at different hierarchy levels of an XML. What is a parent tag? What is a child tag? And then we have looked at a sample notation of product listing, and then we have created an XML based on the sample notation. Then we have added some attributes to our XML, and after that we have validated and formatted our XML. After that we have validated our XML against XST, and then we have checked whether the XML is formatted or not. So all these basics basically help you to start with XML. Why is this important? Just to give you a background, within the PO, the message processing happens using the XML language. So it's important to understand and learn it, because when you do an interface, you're going to validate the XML against the XST. Sometimes you have to check whether the XML is well formatted or not. These are part of the configuration though, but still you have to understand from the ground up how it has been done. Let me walk you through what is XST and its usage. XST stands for XML Schema Definitions, or in simple words, it is Define XML Structure. I use the word XML schema. It's a new terminology you will hear a lot in XML, which actually means representation of structure and content. Schema in general English means representation of a plan. So well, XML schema means representation of XML. That's how I remember it. In XML, we store the data with the markups or tags. It is important to remember that XML has data. XST on the other hand defines how that data should be structured inside the XML. So I'll give you an easy to remember definition. You can say XML has data and XST has rules. It's a very simple definition you can always remember and recollect it. There are cases when you might define the data directly without any predefined structure or references. Means you don't have to define XST for XML. It's not a mandatory. You can even just go ahead and do XML without an XST. But in SAP PO, when we do interface building, we have to first define the structure that is in XST, and in the runtime when you pass the XML, you have an option to validate against that XST, or you can skip it. So it's really important to understand that XST is a part of the SAP PO interface development learning curve. And if you remember the example we previously, where system A sends the XML data to system B and how they communicate, this actually we learned the example in the introduction to XML section, right? I'm just bringing you the same topic back. I assume now that system A and system B follow same XST or rules. So when system A does not follow that XST and sends to system B, then system B can just reject, stating that XML is not valid. It's not following the rules that is been specified in XST. Got the idea? So let's define XST in proper definitions. XST defines what elements and attribute can be represented in XML format. So I use the word called elements and attributes. So remember, these are the two things we are trying to define in XST. XST specifies how should be the structure of XML and what type of data to be used inside each element. We can restrict fields like when a phone tag is been defined, we can restrict the phone tag can only have numbers. When a date tag is defined, we can specify the date tag should have a proper date format. It's like doing a validation on a web page, right? When you filling an email address and when you don't put that @ symbol or domain.com, then the form has not been submitted. It's something like this. It's actually validating against the XST. XST can also decide the number of child elements to be repeated. There's one more important rule that we can define in XST, and that rule is basically decides the number of child elements to be repeated. The property we use is called as min occurrence and the max occurrence. The min occurrence actually say the minimum repetition value, which could be 0 or 1 or 2, and the max repetition value could be unbounded, like infinite or a definite number. This is also called as cardinality. So remember the word cardinality actually means min occurrence and the max occurrence. So when you define the XST, you define the cardinality as well. So let me recap what we learned. So in XST, we generally define the data type, like is it an integer, is it a date, or it's basically a string. Then we define the cardinality of the field. Basically cardinality says how many times the field has to be repeated. XST also define 4 other things, that is a default value, a fixed value, or optional value, and a mandatory value. These are important to understand because now you can restrict the data that user has been entered. Let me walk you through each of those options. The default value means when no value is specified by the user, then this is the default value, right? Means it's an initialization of a variable with a default value. Fixed value means the value is predefined. The user can use the same value that has been defined in XST. The user cannot change the value. The optional means we can skip this field or can be empty as well. A mandatory or required means this field should have some value and cannot be null. Next, let me define the XST and use the rules we discussed. Let's look how to define the XST and how this rules has been applied. Let me walk you through how XST is written. XST is written in XML. This statement should be very confusing to you. As just we described that XST is used to define the XML structure. And now I say XST is written using XML. What I actually means that XST is written using markups. And the language specifications is similar to XML. So don't be confused with XML specification versus the XML data. When I say XST written in XML, I actually means is XST uses the XML specification to define the rules. Let's look at the structure displayed here. Anything we write in XST should start with schema. Well, we discussed this, right? Schema means representation of structure and content. Also, we discussed namespace, which actually starts with XML_NS. XML_NS colon and some variable, to which uniquely identifies the element in the XML. One thing to note that in XST we define how the data should be, but we never define the actual data. The actual data is always in XML. The standard notation for XST schema is like this. It has a URL referring to an XML schema standards. Don't worry too much about what's this URL and where it's coming from. Just remember that this URL actually specifying the XST's definition. Okay, let's continue further. Let me explain to you how to define rule in XST. We will define a price tag rule with two things. First, what content does it hold and how many times this field should repeat. If you're looking at the example, I'm showing an element with a name called price. Now I'm not defining element as the XML field, but I'm defining element name is equal to price. So price is a field in XML. So when you define the XML tags, you're going to write markup or the tag with a name called price. That's what the name is equal to price means. So all the rules that you're going to write in this element will be applicable to the price tag. When we use this price tag in XML, this rule should apply. And what are the rules? The first rule is the min occurrence and the max occurrence. The min occurrence means minimum occurrence of the field in the XML structure. It's easy to remember, right? Min occurrence 0 means it is not mandatory. Min occurrence 1 means it is mandatory. Min occurrence you can think like an optional field, and min occurrence 1 you can think as a mandatory field. However, the max occurrence defines how many times this field can occur. The maximum that you can put is unbounded, which means infinite. Then you can even refer back to any number like 10, 90, 99, any number. The type is another attribute to an element, wherein you can define the data type of the data that is being represented in the price tag. We are defining the type of the price element as integer, which means when we define the price tag in XML, it can hold only integers. Like we can say string or date to represent string value or a date value. So how do we read this line? Okay, let me show you in XML terminology, or you can say XST terminology. The price element min occurrence is 0 and max occurrence is unbounded of type integer, or you can also read in this way. Price element is of type integer and it is 0 to unbounded. Remember what we learned here. All the terminologies that you have learned here are really important in your daily conversation with any of your peers. So when you talk to your colleague, you're gonna talk in this language. You're gonna use the words called min occurrence, you're gonna use the words like max occurrence, and then you're gonna use a attribute called name, and then you can use the attribute called type. So let me summarize this in very simple terms to understand. Element represent field or a tag in XML. Name attribute refers to field name or a tag name. The type attribute refers to data type of the data used inside the tag, like integer, string, date. The min occurrence and the max occurrence decides the repetition of the field, or it is also called as cardinality of the field. Let me run through a simple example of how can we define this XST based on a structure. Let's take an example of the product and then we're going to define it. Let's take an example of a product. Let's say you have a product with two child elements in it called name and price. And then now you want to define a rule like this. You want to say the name should be a string type and should be mandatory, wherein the price should be of type integer and should be optional. Well, this is a real-time scenario. So whenever you're going to design an XST, you're going to receive the instructions like this. They're going to say how many fields should be there under a parent tag or a parent node, and what are the types of each of these fields. They're going to specify what is the mean occurrence and the max occurrence of each of these fields. If you take a look at the example that I've shown above, so if you look at the example, it starts with an element name product, which means there is an element of name product, complex type, and then a sequence. The sequence generally talk about what is the sequence that it has to follow, like you have to have a name first, then the price tag. You cannot jumble it up. The first element is a name element. That's what the element name is equal to name means XML element is called as name. The mean occurrence 1 means it is a mandatory field. The max occurrence unbounded means infinite, and it's a type string, wherein the price that we have seen in a previous example is the same. It's just the mean occurrence is 0 means it is optional. So this is actually the way you define the XST. Next, let's look at how to define the XST and how to validate the XML. So let me show you an example how to create an XST file, then how to validate with the XML, and then finally we'll play around and I'll try to explain you some of the concepts around it. So let's first go and create the product.xst. So the first thing I'm gonna do is right click and create a file, and I'll call it as product.xst. So remember the previous lesson, when we create an XML we use .xml. Now when we create an XST we have to say the extension as .xst. Save this file, then we'll use a notepad or any notepad that you generally use. Then now we start writing this XST file. So I'm going to walk you through general definition of how to write an XST. First we have to define the XML declarations, which is version 1.0. Then we're going to define with a namespace schema, and schema is generally the first tag of the XST. Then we're going to say what is the namespace XML ns :xs, which is equal to, and then we're going to refer to the XST schema. Don't worry where this URL is coming from, but just try to concentrate how I'm trying to write an XST. So every opening tag should has a closing tag. So let me close the schema tag. Next we're going to define the element. And the name generally is the name that we're going to use in the XML. So I'm trying to define a product. Then we have to say this is a type of parent node, so we can say this is of a complex type. It generally indicates there are some child elements in it. Then we define the sequence. So you can generally say what is the sequence of the child fields. I'm just going to give you some indentation to it just to look good. So now I will start defining the elements again. So first let me define the name, and this name is the name of the tag. Then I'm going to define the data type. So it's similar to defining an variable, and you can close the opening tag with a self closure tag just by saying like this. Means you don't need to specify a closing tag, it's just like self closing tag. Then you can say it's a description, then the price tag, and this time this can be integer. So let us go back and test this with an XML. So what I have done just now is I have loaded up the XML, and then I have added the XST here, and the tool that I'm using is utilities-online.info. Okay, so the first thing we do is we check whether the XML is well formatted. Yes. Then we check the XST is validated, which is well formatted, right? So one thing I have done is I have added an additional parent node called product listing. I just want to test it out because I haven't mentioned those parent node anywhere in the XST, so I just want to see what's going to happen. So definitely it's going to say that it cannot find the product listing, right? So let's try to remove this, and then we will work out with the XST. And then now let's see whether XML is validated. So now even if we remove the product listing, now the second error is saying the $99 you mentioned is at integer, but now you're actually not using as an integer, but you're adding some kind of symbol to it. So let's try to remove this symbol. Okay, so now the XML is validated against the rules file that we have written in XST. Let's try to play around with it. Let's say I will add the min occurrence and the max occurrence. So let's say I say min occurs is equal to minimum 2 max occurs 3, right? So this should error out because the name is not repeated twice, it's just once. But now we say the minimum occurrence should be 2, right? So it says one more name is expected. Okay, so let's duplicate this one, right? It works back. So now let's see if I can change the sequence to say the description is first and then the name. Then it should be error out to say you're not following a sequence, right? So let's change back the sequence. Well, you can retain the schema, you can change the XML and follow that specification, then they should work, right? Next, let's try to add min occurrence. That's the optional field. Let's say min occurrence is equal to 0, which means the minimum occurrence is 0 and it's an optional field. You can actually remove it. You don't need it. Let's say I'm gonna use unbounded here. First thing I'm gonna do is check the validity. It's fine. This should work fine. Now I try to remove this. Even though I say price is an element and type of integer within a sequence, but I'm saying the mean occurrence should be 0 and there's no issue in it. Let's say I change the mean occurrence to 1. It should error out because the price is expected, right? And there's no price tag, but we say mean occurrence is 1. So when we say mean occurrence 1 and unbounded means you can have n number of price elements, and this should be a valid document. Well, I hope you have got the idea of how to write an XST and how to validate against the XML and what are the rules of the XST. I've just given you a very basic definition of XST and very basic definition rules and the important rules when you define an XST. I'm just going to run through what are those rules. First thing, you have to define everything within the schema. The second, when you define a parent-child relationship, you need to have a complex type. And then when you define a sequence, you need to follow those sequence. And then there's something called as name and type. Name is the name of the XML field. Type is a data structure. The mean occurrence actually say how many times the minimum the field should occur. When you say mean occur as 0, means it becomes optional. When the mean occurrence is 1, it becomes mandatory. The max occurrence can go up to unlimited. That's referred with an unbounded. Okay, so that's it all about XST. Let's now look at DTD. Let's now look on what is DTD. You need to understand that DTD and XST does the same job. They both are the rule file for XML, and conceptual wise they both defines the rule that XML can follow. XML can follow the rules from DTD. XML can also follow the same rules from XST. Then what's the difference? Well, DTD came first, then the XST. After working with both, I can say DTD is used for simple types and XST can be used for both easy and complex scenarios. The major difference to remember is DTD syntax is based on HTML. It does not look like XML, wherein XST is a pure XML language. So the advantage is we don't have to learn something new or remember something new when we deal with XST, wherein DTD you have to learn HTML, which actually means standard generalized markup language. Let's look at what is DTD. The DTD stands for document type definitions. It defines the element structures and what the data is holding. It's similar to XST, right? So it actually does the same definition of the fields. However, there is not many options to differentiate data types within the DTD. It's very limited. There are two types of data type which is commonly used in DTD. The one is called PC data, which is called as parsed data type. The other one is called as unparsed data type, referred with the C data. Most of the times we'll be working with PC data type, which means you can include all the character set in it. Unparsed, generally you don't want to parse at the runtime. Like XST, the DTD also does the same job. DTD defines the attribute of the elements. DTD also take care of ordering and nesting of the elements. As I told you, the only difference you will find when you try to write DTD uses HTML. That's why you can find the syntax of DTD is something different. It's a markup based, but it's not really XML. Well, DTD is very simple and easy to build. It's part of the initial design, so you can understand why there's not many complex things inside. And what is my preference when I want to use DTD or when I want to use XST? My rule is very simple. When I want a very simple, quick DTD, I would say, I just open up the notepad and start typing the DTD. It's a very sleek and easy to write design with not many complex structuring. When it comes to XST, it's very complex to write, but it is scalable. And I always prefer XST when I want to write something complex scenarios, and then medium to complex, I always prefer XST. Let's look at the DDD definition now. Let's learn how to write the DDD. The first thing that we need to write is start with a declaration. The declaration start with the doc type, and there are two types we can write the DDD. First is inline and second is external. The inline means you can write the DDD inside the XML itself. That's why we say DDD is very slick. External means you can write the DDD in a file, save it with an extension called .ddd, and then use it as a reference in the XML to validate the XML. So that's two types you can actually define the DDD. And just remember, when you write a DDD, it should start with doc type. Let's try to build one, and then I'll walk you through the definition of all the fields. Let's look at two different samples of how to create the DDD. The first, we will look at external DDD, then we'll look at inline DDD. You can find numbers 1, 2 and 3. 1 and 2 actually is external DDD. 1 is defining, 2 is using. Third one is inline DDD. So let's look at 1 and 2. The number 1 generally is a DDD file, means you create a file with the extension called .ddd, and then you write this code inside it. So let me walk you through what this actually definition means. You always start with exclamatory mark element. As we saw in XST, we always say element is the same keyword we use in DDD called element. The first line that you have to write in DDD is to define the structure. You're defining the ordering and the nesting of the elements. So you say product actually have name, description and price. Here you are not defining the min occurrence and the max occurrence and the data type. The only thing that you're defining here is the ordering of the fields, the parent and the child relationship. Then you will go into individual fields, and then you will define what is the data type. As I explained previously, it doesn't have so detailed data type. You just differentiate with PC data and the C data. And if you're trying to store the data like string, integers, date, then we prefer to have PC data. Wherein if you want to store some data and don't want the browser or the compiler to compile it, then we actually use it as in C data. So here we say product have 3 fields. So product is a parent, and name, description, price is a child of it, and name is PC data, description is PC data, and the price is PC data. It's as simple as writing the rules file. Then in the XML, that's the number 2, you will import the DDD. So as I mentioned, the doc type is important. You don't mention doc type in DDD, you mention that in the XML file. So that's like an import statement also. Doc type is actually the declaration of the DDD. So you say doc type of type product, and then system means you actually referring the file from the system, which is a product.ddd, and then you define your XML file. So when this file is been executed as an XML, it will refer back to its DDD and then try to validate the definition that's written in the DDD. Let's look at the third option. That's basically the second option of inline. Inline means you write the DDD and XML within the same file. So here you're not gonna say system and then refer to an external file. Here you actually write the whole DDD. So if you look at the example, it starts with doc type product, and then inside that product you actually define the elements. You define the sequence, then you define the data type of each of the fields, and that's it. When this file is executed, it actually loads up the DDD and then validates against the XML, and if there is an error, it will just output it out. I hope you should fairly get an idea on what is DDD and XST and how it is used in general terms. Let's now summarize what is XST versus DDD. Let's see what are the things we have learned in DDD and then compare against the XST. Well, the DDD is based on HTML, and you know XST are written in XML. DDD supports limited data types like PC data and the C data. wherein in XSD we have wide range. XPath is a So let's start defining what is XPath. In a simple term, XPath is a syntax for defining parts of the XML element. So let's look this definition with an example. So what I've done, I have taken an example of product, just we have seen in the previous courses. I've taken a product XML and then I will use XPath to navigate through it. Remember, XPath is a path expression. So you're going to use path to refer to any of the fields and get that value. So let's start developing an XML and then I'll walk you through how to define the XPath. So now let's look at how to write this language. What we learned is how you define the XPath and how you can correlate with an folder structure. Now let's look at the real XPath notation. On the left hand side, I'm showing you a sample XML. I'm not taking the previous example, I'm taking a little complex, wherein you have a class and you have students in it and then you have teachers in it. And the students actually have sub elements which are student, and each student has a roll number or an ID number with his name. So teachers also have an ID with ID as an attribute to teacher tag, and each teacher has a name. So you have students and teachers as an batch. So this is how you can define it. Class has two sub nodes, students node and the teachers node, and students node has sub elements which are student with an attribute called ID and with some name, and teachers also have an ID as an attribute with some name. And if you see the prefixes that I have used or the namespaces I have used is starting with XML NS:S and XML NS:T, just to represent S as a student, T with the teachers. On the right hand side, I'm trying to explain you the definitions or different ways to access XML. The first example is a /. That's what we have seen when I try to explain you with Windows example. The / is generally used to represent any node name. So you can say /, then a node name, then that node's value you can refer to. Actually, when you say / and a node name, the whole element is selected. So when I say / and a student, then the whole element is referred. When I say I want to select the class and all the subsegments in it, then I just have to say / and a class. That's the second example. The third, let's say you want to access all the student under the class and under the students. Then you say / class and then students and then student. And then student is a repetitive element, right? It has 3 repetitive elements with an ID 100, 200 and 300. So which one is selected? Well, if you say class, students and student, all the 3 are selected. And when I say selected, when you write a program to access this XML using that XPath, the return value will be 3 elements. That's the 3 student element. Let's say I want to access teacher with an ID 1. That ID is an attribute for the teacher tag. So now I'm using a new notation called /. The / generally means you can access any node directly without representing its parent nodes. So if you see here, teacher is inside the teachers and teachers is inside the class. So instead of saying /class teachers, I can use // to directly refer to a teacher. Then I open up a square brackets just to notate that I'm going to write a condition in it. When you want to access an attribute, you use the symbol @. So @ID means I'm trying to refer the attribute of a teacher. And I can say @ID is equal to 1 means I'm trying to refer to all the teacher tag that is accessed with /teacher. Within that, I'm writing a condition to pick only which matches this condition. And the condition is the attribute ID should be equal to 1. The fifth example is a function. So in XPath, you have different type of built-in functions. And one of the function is count. You can count the number of elements is repeated. Let's say if you say // means you can directly access the student, and that's basically a 3 element, so the count will be 3. The next is if you want to access the text. As I was telling you, all the while you can get the element, means starting tag, the data, and the closing tag. That's why if you want to access only the text without the tag, starting and ending tag, then you use a function called text. And then if you look at how I'm representing the first element of the student, that's basically an array, right? Let's say if you want to access the second element and the third element, you can just specify // student square brackets, and you can say 2 or 3 / text function to access the value within that element. You have many functions in it. There's one more important function is called last. Let's say you want to access the last element within that segment, and then you can say last as in the square brackets. You can say // student. This time don't mention the square bracket, just say student, so you get the whole array. And then you say a // then you can say square brackets and the last method. So I will try to do a simple example using the online tool, and then we're going to play around with all the methods that I told you, like count, text, last, and then we're going to play around with how to access the attribute, and then you can learn along. Okay. And before we jump into doing some of the samples on the online tool, I just want to give you these expressions to remember. This is like a recap. The // means a root element. // means you can select any given node without specifying its parent nodes. A single dot represents the current node, and the double dot represents the parent node. This is similar to how Windows used to represent a single dot and a double dot, right? Nothing new. Then you have the square brackets, as I shown you previously. Anything that you can write inside the square brackets will act as a condition. Let's say an example wherein you are trying to access the student and you get 3 student element. Then you can use a square brackets to say I want which specific student. You can write condition like last to say I want the last element, or you can say numbers to assign to say which array value do you want, 1, 2 or 3. If there are attributes available for student, then you can use this attribute as a condition to pick that specific value. And last, they have some functions, so next we play around with those functions. So we're going to do 2 things. First thing, we will try to generate the XPath. So we'll learn how to create the XPath. Second, we will use those XPath's value to get the output from the XML. Okay, so I'm going to use 2 different tools, which I'm going to show you here. The first tool is going to use to generate the XPath. We'll try to understand how to create the XPaths. The second tool will help you to understand how to use those XPath to do a query on your XML and get the output. Okay, so let's look at it. Okay, so let's try to build the XML. Then I'm going to compare that XML XPath with the Windows folder notation, so at least you can see how it is being related. So let's say in an XML we have a product. So I'm going to define the XML, and simultaneously I'm going to create the folder path inside the Windows. Okay, so let's say the product has name. Okay, let's give a name called PO Guests. Then some description. Right, and then we're gonna say some, maybe we can say price, and say some price to it. Okay, so we know we can define XML using tags, and as I told you, XPath is nothing but a path that you can refer back to an XML's node, right? So typically when you write an XPath, the XPath starts with a /, right? But this Windows, so it actually uses its own format. So let me try to show you, if you want to access product price or product description or product name, how you're gonna access it using XPath, how it's actually shown inside the folder structure. Let's say you have a folder name called name, then you have description, then you have price. So this is how we're actually defining it. It's a product has name, so when you click name and you see the path, it has the backslash product backslash name, right? If you have to show this in XPath, actually replace this with / and then the / product and / name. This actually is XPath to refer to a name element inside the product. Similarly, you can do it with description, and you can do it with price. The notation is same and the idea is also the same. That's how you're gonna accept it, right? So this becomes your XPath for price to access within the XML. Got the idea? So let's try to build a substructure in it. Let's say you have a course in it, right? Then you can again have a title for the course, that is the introduction to XPath. Then you can have the price for the course, right? So how we're gonna show this notation in XPath? So let's say we use the same Windows folder and try to show this. So course has a title, and then a price, right? So if I have to access title for a given course in a product, so the XPath notation will be product course title. It's as simple as that. This is how you can refer back to a specific field or an element within an XML with this XPath notation. So if you see the XML XPath for title, this is how it's going to look like. It will have a /, then the parent name, then the child name, and then the actual tag name. So let's look at two different tools. The first tool is to generate the XPath. The second tool is actually used to use that XPath to get the data from the XML. So the first tool I have loaded up with an XML, and it's an XML of the class example that we have seen, and this time I have removed the namespace so that we understand the XPath concepts easily. Actually, you can use a namespace also, it's just you might be confused, so I just removed it out. So let's say in a class you have students and teachers, and each students actually have multiple student in it. Even teachers have multiple teacher in it. An ID is an attribute, and each student actually have a value assigned to it. So let's say how to access a class and what is XPath. So when you click at the class, you observe the XPath results. So when I say class, I actually get the /class. So this is the way you can access the class, and when you say /class, you actually get the students and all the teachers inside it. And when you want to access students, then you click students. This time with this XPath, you're not going to get teachers, you will only get students, because if you look at the structure, students and teachers are at the same hierarchy. So when you access a parent node, only that parent child you can get. You cannot get the parent of another siblings. Okay, understood? So let's say I click on teachers again. So this is the way you can access teachers. And let's say if I want to access student, yes, I get the student. And if you observe, I get a array kind of example, so which indicates I'm trying to access the first element. And if I click on the second element, I get the second. If I click on third, I get the third. If I click on teacher, I get the teacher first, teacher second, and teacher third. Right? Let's try to click on ID and see how to access the first student with ID 100. Right. So you're actually seeing, if I say student of 1 @ ID, The @ symbol is actually used to refer to an attribute. As an ID is an attribute, I am actually referring to the first element ID. Similarly, I can refer to second, third, then teacher ID, second and third, right? And if I have to access the value, I said we use a function called text. So it's student of 1 of text, student of 2 of text, student of 3 of text. Similarly for teacher, teacher and teacher, right? Yeah, this is how actually XPath is used to access an element in an XML. Okay, so we have learned how to generate the XPath. Now let's look at another tool to use the XPath to access the XML. Well, we understood XPath is used to access an XML, right? So we'll use the XPath that has been generated and we'll try to execute an XML and see how's the output. So let me pick the first example, that's a class. And when I enter the class, I actually get the whole segment in it, right? I get the class, students and all the teachers. And I just try to type from here, like the students. Then I get the students element, the whole segment, right? Not just the element, but the whole segment. And if I say teachers, I get the teachers, right? And if I have to access teacher directly, I say we use /, right? So you get the teacher. Similarly, you can access student, right? So in the previous example, I shown you that when you try to access with /, you actually get the whole element. This is what I was referring to. You cannot get the text of the element. To get that, you need to use that text method, right? So you can see you actually get the text element with all the names in it because the student is referring to all the elements. So now you can use the square brackets to say I want to access the first one or the second one or the third one. Then you can relate back that specific element. And let's say I want to say ID of type, right? You can use the symbol of @ to represent an ID and say ID equal to and say 100, right? You still get the Ray Charles. Let's try to change this, right? This time you get the second one. You can even do the third one. I hope you got the idea, right? So first thing is to generate the XPath. So you need to understand what XPath you're trying to access. And the second part is basically to run that XPath on the XML to get the output. And most of the time you use XPath to get the value of that particular field. I hope by now you got the idea on what is XPath and how to use it to read XML fields. In case if you didn't really get it or you forgot this topic, in future always compare it with folder path style and you will never go wrong. All we were doing was using XPath to navigate the XML tree structure, right? That's how it's to remember. Finally, let's summarize the usage of the XPath. Well, XPath is a syntax for defining parts of an XML document, and XPath uses path expressions to navigate in the XML document. And then the path expressions that we have seen was /, //, those kind of notations. XPath contains a library of standard functions like we have seen as text and then last and then count. And yeah, XPath is fastest and easiest way to read XML. Remember this, as you will find many other ways to read XML, but XPath is lightning speed and standards too. Hello and welcome to the Web Basics. Let's look at what is the communication challenge gap that we have. Okay, let's understand a challenge that we have in terms of communication and how this web actually help us to solve that challenge. So before that, let's understand what is the challenge. So let's meet two friends. One is Jim, and Jim is from USA, and one is Bob, he's from Australia. Okay, and Jim is thinking about something. So Jim is thinking, I want to buy a phone for a cheaper price. Okay, and he's looking for a phone in the market, and he's always thinking, how can I buy a cheaper price iPhone maybe, right? And Bob is in Australia. He want to sell a phone for a cheaper price. Well, there are two different kinds of people. One is called as buyer, who want to buy things, and one is called as seller, who want to sell things, right? And what is the challenge that they have? They have this communication gap. The gap between buyer and seller. Buyer want to buy it and seller want to sell it. Well, how they can find themselves and how the communication gap can be reduced. This is the challenge here. That's basically the communication gap between a buyer and a seller. Okay, let's understand two challenges that we have. Well, challenge number one is the language. Does Jim and Bob speak same language? That's the first challenge. The second language is a distance. How Jim can find Bob? Well, to solve this communication challenge, you have to solve these two problems. The first problem is, does Jim and Bob speak same language? So you have to agree on to one language, and then you also have to solve a distance problem where Jim and Bob can communicate with each other irrespective of their distance. So let's take this challenge and understand this, and let's understand what are the definitions of protocol, TCP/IP, internet in terms of solving these two challenges. The challenge number one is the language, where does Jim and Bob speak same language? The challenge two is the distance, how Jim can find Bob. Okay, so that's the challenge of communication gap. Let's understand the other things. Welcome to the lecture. Let's understand what is protocol. Let's do a quick review of what challenges we are solving it here. So we have seen up the communication gap between Jim and the Bob, wherein Jim is a buyer, Bob is a seller. Jim want to buy a phone and Bob want to sell the phone. The two challenges is, challenge one is the language challenge, where Jim and Bob speak same language. The challenge two is the distance, how Jim can find Bob. Okay, so let's move on. Okay, so this is the challenge. Let's see how we'll solve this challenge. So let's understand what is protocol. Okay, so Jim staying in USA and Bob staying in Australia, they might be speaking different languages. Okay, so the first thing they have to have is the agreement of the language. If they want to communicate, they have to say, okay, let's speak a similar language. Okay, so that we can have an agreement of a language first, so that we can speak, right? And that is nothing but a set of rules. Well, language is nothing but a set of rules, right? Language defines of what alphabets to use, how you pronounce them, and what words do you use, right? So these are basically the rules of a language. So in terms of protocol, protocol is nothing but set of rules. Okay, when two people communicate each other, they just typically agree onto a language. So if they speak the same language, then the communication can happen, right? In terms of a protocol, protocol is nothing but set of rules. Well, if Jim and Bob want to communicate with each other, the Jim says, let's speak in English. Then Bob says, all right, let's talk. So the communication gap has been removed. That is the first level of communication called as language communication, right? They agree onto a protocol, and protocol define what rules to use for that communication. Okay, so understand this concept of a protocol. When someone say what is protocol, it is nothing but set of rules, right? It is a rule using which you establishing the communication. In between the two people, we agree onto a language, could be an English language, right? And once we agree onto the language, then the communication can happen. Well, that solves the first problem. Does Jim and Bob speak same language, right? When they agree onto a similar protocol, so there has to be an agreement of protocol first. When two people want to communicate, there has to be an agreement of protocol so that these two people can communicate. Okay, so let's move and understand how these things happen in terms of computers. Well, how to system communicate? Even for a system to communicate, they have to follow a protocol, so that when a system communicate with each other, they first define what is the rules we're going to use to communicate. That is the first transaction that happens between the two systems. That is nothing but they follow a same protocol. They agree onto a protocol first before the communication can happen. Okay, so let's take an example. So think of an example of a TV via your remote. Your remote is trying to control your TV. How do you think your TV remote can talk to your TV? That's basically an agreement of protocol called as infrared protocol. This is the protocol that is programmed in the TV remote and also in the TV so that they communicate via this protocol. Take another example of your phone via your Wi-Fi devices. You use nothing but a Wi-Fi protocol. So there is an agreement of protocol wherein your phone basically can talk to a Wi-Fi device. And also if it's a headphone, can you guess what is the protocol that we use to connect your headphone to your phone? Well, that's right, that is your Bluetooth protocol. So you see, for every devices to connect, irrespective of mobile devices or any of the hardware devices, there has to be an agreement first. So remember this, there is an agreement always happening between your devices before the actual communication can happen, before the actual data transfer happens. So they agree onto the same protocol, okay, same set of rules, agreement of a same language. So now when Jim uses his PC to communicate with the Bob PC, okay, they use a protocol called as TCP/IP. We're going to deep dive into TCP/IP protocol in the next lecture. But on a very high level, we say that when two PC communicate, they have to agree onto a protocol. Okay, and if two PC want to transfer data, they agree onto a protocol called as TCP/IP. TCP/IP is a protocol using which we can transfer information between computers, and obviously you know the information between computers is zeros and ones. So all the zeros and ones that has to be transferred over between two computers is happening via this TCP/IP protocol. We're going to deep dive into what is this protocol all about in the next lecture. But on a very high level, understand this now. When Jim computer want to talk to Bob computer, they use something called as TCP/IP protocol. So how this communication typically happens, right? The first thing that happens is Jim send a request. That's where the data transfer of TCP/IP happens. Someone has to initiate the request. So Jim PC basically send a request to Bob PC saying that, hey, I want to buy an iPhone. Then Bob PC can respond saying that, okay, this is my response and I'm interested to sell my phone to you. Okay, so that's basically the communication that is happening between the two PCs. And that's how the challenge that we have seen previously, how Jim can buy a phone and Bob can sell a phone, challenge can be solved via this communication. Okay, so let's understand what is a protocol. So what is protocol? Protocol is nothing but set of rules. Remember this definition forever. Okay, if someone asks you what is a protocol, think it as a set of rules, some rules that is being defined already in that protocol. So protocol is nothing but a set of rules that defines how to communication can happen between the two devices. As I told you, two devices has to agree on to the protocol first, then the communication can happen. Every machine is programmed with a protocol that is nothing but the rules to communicate. If two computers are talking, if two hardware is talking, if a machinery is talking to another machinery, there is something called as protocol already been defined. Okay, the protocol is something like an handshake. They first say, okay, let's start communicating and this is the language I'm going to use. Then the other person agrees to that language, then the communication happens. Okay, so devices agree on a common protocol before they communicate. This is a very, very important line that you have to remember always when you think of communication between the two devices. Any two devices in the world that you take in, they first agree onto a protocol. Once they agree onto a protocol, then they start communicating on that protocol. And what is a protocol? Protocol is a set of rules. Well, here is some of the examples we have seen previously. Protocol is a set of rules to communicate. Your phone can talk to your Wi-Fi devices using a Wi-Fi protocol. Computer can talk to a server, download files, upload files via an FTP protocol. You are sending emails, then obviously it is basically an email protocol. Well, that's basically solves the first challenge, that is the language challenge. And the language challenge is solved via the protocol. So they first agree onto a protocol. So in terms of Jim computer and the Bob computer, they agree onto a protocol called as TCP/IP protocol. And Jim initiate the request to say, I want to buy a phone. The Bob send a response to Jim saying that, okay, I'm going to sell the phone to you. Well, so challenge one, that is a language challenge. Does Jim and Bob speak same language? Is solved via agreeing onto a protocol. Okay, and what is a protocol? Protocol is a set of rules. So let's look at the challenge number 2, that is a distance. How Jim computer can find Bob computer. Okay, so let's understand this definition by understanding what is internet. All right, so let's jump in another lecture, understand what is internet. Hello and welcome to the lecture. Let's understand what is internet. So let's look at the problem that we are solving it here. We have solved the first challenge, that is the language challenge, how Jim and Bob can speak the same language. We have solved it. Now Jim and Bob agree on to the same language and then they communicate. So let's understand the language number 2, that is the distance problem, right? How Jim computer can find Bob computer. And in terms of understanding how they solve this problem, we'll understand what is internet as well. So let's look at this example of transfer of information via the computers. We said that we will use TCP/IP protocol. TCP/IP protocol is basically helps you to transfer information from one computer to another computer. Okay, let's take an example of your TV remote via a TV, where we agree on to a protocol saying that infrared protocol is used to communicate between your TV remote and your TV. So that's not a problem. So communication can happen. You can control your TV with your remote. But the problem is there is no distance problem between your TV remote and your TV. Okay. Obviously, we know if you take your remote and go out of your house and try to control your TV, it will not happen because your distance is a problem, right? That's where the challenge that we are trying to solve it here. When there is a distance, how they find each other, right? How they try to communicate when there is a distance. Well, if there is no distance, then there's no problem. Like if you stay in your home, your Wi-Fi is not a problem. If your headphone is nearby you, then that's not a problem. If you move away from your headphone to your phone, then the distance challenge come in picture. Language is not a problem, because once the distance is not a problem, language is not a problem. Language has been agreed, but when the distance come in picture, then that's where the challenge that you have to solve. Okay, so let's understand if distance is a problem, how do you solve that challenge of communication? And in terms of Jim and Bob, okay, Jim stays in USA and Bob stays in Australia. Obviously distance is a problem here. And how Jim computer can talk to Bob computer when they live in two different regions so far away. Okay, so let's understand how this problem can be solved. So let's understand what is internet. Okay, internet is a network. Okay, remember it is a network where group of computers connected together with a single wire. You have all these computers in the internet, they all connected with one wire, irrespective of where they stay. If you are connected to an internet, you are actually saying we all are connected via a single wire. And why you have to connect via a single wire? So that you can find each other. Well, think of how the current flows in through your house. Okay, all the current that we flows in through our house is via the power cables, right? All the power cables or the current cables that is connected all over the world, sending all this current back to our house, right? Similarly, in internet, all the computers are connected to either via a single wire, so that the information can be passed via these computers and they can be reachable via the single wire. Okay, so that's the concept of an internet. So when someone say what is internet, it is nothing but a network, right? It's nothing but a network where all the computers are basically communicated with a single wire, so they can communicate, they can find themselves and they can communicate. Okay, so let's look at what is the purpose of internet. All the computers in internet can find each other and connect. That is the only purpose that internet exists. So let's take a step back. Now let's understand Jim and Bob's problem. Well, Jim's computer is in USA and Bob's computer is in Australia. So with the help of the internet, means if Jim computer can connect to an internet and Bob computer can connect to the internet, then they all are connected via a single wire, and now they can find themselves, because internet is a network where all the computers can be reachable, can be found, right? They can be found, they can be connected, and you can send information between the two systems via the same protocol, that is TCP/IP protocol. Okay, so that's how the internet can solve the problem of the distance. So once Jim can find Bob computer via the internet, then Jim can send a request to say buy phone, and Bob can say send request to sell the phone. That's how the Jim computer can find Bob computer via the internet. So let's look at the definition of an internet. Let's do a quick reference of what we have seen so far. Internet is a network where group of computers connected together with a single wire. Systems connected in the internet network are able to communicate with each other and exchange data. That is the main purpose of internet. You can connect to internet to access other computers and exchange data via TCP/IP protocol. So that's the purpose, right? So if Jim want to find Bob computer, they connect to internet so that they now can be visible and they can connect with other computers that is visible in the internet as well. Well, that's the purpose of internet. So let's understand whether we have really solved the Jim and Bob's problem. Well, we have seen Jim can now connect to internet, Bob can connect to internet, everything is fine. They can find themselves and they can connect themselves. But there's one problem. There are billions of computers in the internet. With billions of computers in the internet, how Jim computer can uniquely identify saying that, oh, this is a Bob computer, let me send a request to my phone. Okay, internet is a place where you can connect to all the computers, but how do you identify them? How do you identify a specific computer in the internet? That's the challenge, right? How Jim computer can identify Bob computer. Let's understand how this problem can be solved. Okay, and this problem of identifying computers can be solved via this protocol called as TCP/IP protocol. TCP/IP protocol is a protocol used to exchange data. It has some definitions also attached to it. Means you have a set of rules to follow. Once you follow this and you are reachable, then TCP/IP will take care of communicating to a specific computer in the internet. Okay, so let's understand what is TCP/IP and understand how you can solve this challenge, like how Jim computer can identify Bob computer. Okay, so let's look into that in the next lecture. Hello and welcome to the lecture. Let's understand what is TCP/IP protocol. Let's do a quick recap of what challenge we were stopped at in the previous lecture. Well, Jim computer can connect to internet, Bob computer can connect to internet, and they can find themselves. But the challenge in internet, there are billions of computers. So how to uniquely identify the computers? How Jim computers can identify Bob computer? Okay, so let's solve this challenge by understanding the TCP/IP protocol. Let's take an example of internet, right? In internet, we say there are billions of computers. So how can you uniquely identify them? You can uniquely identify them by giving them a unique number, right? Once you give them a number, okay, then you can uniquely identify them using that number. And this number is basically nothing but an IP address. Okay, every computer have a unique address, that is the number in the internet, which is called as IP address. So every computer that connects to the internet gets this unique address. There cannot be duplicate of unique addresses. There has to be unique addresses when you connect to an internet. Even though you are connecting to the internet via your Wi-Fi, you actually get a dynamic IP address in the internet, so that you are identified uniquely in the internet. Okay, so what is IP address stands for? IP stands for Internet Protocol, that is used in the internet to communicate between the systems. Once you have an IP address, then you can identify yourself and then the communication can happen. Example could be like a phone number for every SIM. How do you identify a unique phone in the whole world? You have a phone number. And how do you reach to your friends? Like how do you make a call? You call via the phone number. Similarly, in internet, if you want to reach to a computer, you reach via the unique address, that is nothing but the IP address. So that solves the challenge of identifying a computer in an internet by assigning each computer an unique address. Let's understand what are the details of his unique address, and this address is called as IP address. So once the IP address is assigned to each of the computers in the internet, now using this protocol called as TCP/IP protocol, they can uniquely identify that particular IP address and then they can establish a connection and transfer the data. Okay, that's the rules of a protocol, that you need to have an IP address first, and that IP, using that IP address, this TCP/IP protocol will communicate, establish the communication and transfer the data. Okay, so every computer in internet has a unique IP address, and TCP/IP is a protocol used to connect and communicate. Remember these definitions of what is IP address, what is a TCP/IP, what is the purpose of TCP/IP, and how IP addresses are assigned to the computers, and why you need to have a unique IP address in the internet is just to find themselves and establish a communication. Okay, so let's understand how the IP address looks like. So IP address is basically unique addresses which is separated with something called as dot. So if you look at here an example, 192.87.45.20, this is a number that is assigned to a computer in the internet, and this is how you represent an IP address. Let's look at an example of what is an IP address. So I have opened up a command prompt. Okay, so how to find my IP address? Okay, you can go to ipconfig. Once you click on ipconfig, you will see something called as IP address. An IP address is separated with a dot. Okay, and it has 3 numbers in it. Okay, that's how a IP address is been assigned to a computer, and this is a dynamic number. Whenever I log off from the internet and log in again into the internet, maybe this number will change. Okay, and every computer in the internet has something called as IP address. Okay, and if you have to find an IP address of yahoo.com, you can say www.yahoo.com. okay, you will find the IP address here. Okay, we'll understand what is this and what is this. This we know is an IP address. This is called as host name. So in the next section of what is DNS, we'll understand what is this and how this thing work. But for now, focus on what is the IP address. This is the address using which I can use the yahoo.com server. If you want to ping the google.com, okay, you can find an IP address. However, this will be dynamic for Google because they have many servers, right? So you might be reaching to a different server every time you do a ping. Okay, that's a different concept altogether, but remember for now that every computer in the internet can be found via this something called as IP address, and it looks like this. You have 3 integers dot, then 3 integers dot, 3 integers dot, 3 integers. Okay, so that's how the IP address is used to identify a computer in the internet. So now that you know what is an IP address and how it look like, let's do a quick recap of what is TCP/IP. TCP stands for Transmission Control Protocol and is used to connect and transfer data. Remember this definition of TCP/IP. The purpose of TCP/IP is basically to connect and transfer the data. To connect, it has to find out what is the IP address first. So in order TCP/IP to work, it should know what is the IP address. And IP stands for Internet Protocol, using which any computer can be identified with a unique IP address. We have seen yahoo.com, google.com. By just doing a simple ping or using a command called ipconfig, you can find your own computer IP address. When you are connected your PC to an internet, you will definitely have a unique IP address, and that is nothing but the Internet Protocol. And now you can connect to internet to access other computers and exchange data via the TCP/IP protocol. So how you can access Google, how you can access Yahoo, all these computers that is Google is hosting or Yahoo is hosting can be reachable via the IP address. Alright, so let's go back to Jim and Bob's problem. So now Jim computer can identify Bob computer via a unique IP address. If you look at the diagram here, every computer that is in the internet have a unique IP address, and then the TCP/IP protocol now can work. The transfer of data can work, and each computer can identify itself with a unique number. So the problem of Jim computer identifying the Bob computer is really solved by using the IP address. Okay, with the IP address, everyone can reach to any computer that they want. It's similarly to your phone numbers. You can reach to any phone by dialing that phone number. So there's one more challenge attached to this. Well, however, there is one challenge attached to this. Let's understand what is that challenge. Well, it is hard to remember billions of IP addresses. You see, the IP addresses is so funny. Well, IP addresses are hard to remember because these are integers, and if you have billions of computer, you really cannot remember these numbers. And if it is dynamic, let's say you're connecting to internet and then you're logging off, again connecting, then you get a dynamic number. So it's again not a static number, right? It might be dynamic number, or it could be a number that is very hard to remember. So the challenge is, how do you remember these numbers? This number can be remembered via a DNS name, that is the domain name service. Think of how do you store a phone number in your phone, right? There is a phone number, and then in the context you add the name to it. That name is nothing but domain name. Let's understand domain name in the next lecture. Welcome to the lecture to understand what is DNS, that is domain name service. Let's look at what challenge we're going to solving it here with the DNS. We said that every computer in the internet have a unique IP address, and that's how the IP address looks like, but it's hard to remember billions of IP addresses, right? So how do you solve that challenge? So let's understand that. Well, that can be solved via something called as DNS. Okay, every computer in the internet which has an IP address, you can give an English name that is easy to remember name. That is nothing but domain name service, DNS. Okay, DNS is nothing but an English name or an easy to remember name for your computer which has an IP address. Remember, you need to have an unique IP address, and to that unique IP address you assign the domain name system. And why do you do it? Why I have to give a domain name for an IP address? I can just use the IP address as I want. I don't want to have a domain name. Well, there's no problem, right? You can connect to any computer via the TCP IP. That is the rule of the protocol. You need to have an IP address. It's not a rule that you should have a DNS name, but you can even connect to any computer via the IP address. That's fine. But imagine a situation wherein you have to remember thousands of phone numbers, right? What you typically do is you, in the contact list, you assign a name to a phone number so that you don't have to remember the phone number. And really it is hard to remember numbers and it's easy to remember names because the numbers are complex and it is difficult to remember. We have something called as domain name system, which gives us an English name to our IP address. Okay, so let's take an example. Okay, so we have a computer in the internet having this IP address. We can assign a host name or a domain name. You can even call this domain name or a host name something called as phptraining.com. And once this name is assigned to this IP address, so if you have to find the phptraining.com server, you don't have to remember the IP address now. You only have to say phptraining.com and you will connect to my computer. Okay, so remember, there is a linkage between your IP address and your host name. You have to create this link. First of all, you have to have this domain name purchased. Again, the domain name has to be unique, obviously, right? So you have to have a unique domain names, and each domain name is assigned to a computer's IP address. Well, if you want to have a name for your computer in the internet, you have to buy the domain name. Okay, so let's understand who sell this. So there are two types of providers in the market. One is called as web hosting providers. One is called as domain name providers. The web hosting providers sell space in the server. Typically, web hosting providers have the servers with IP addresses in the internet, and these servers are very huge. Okay, they have tons of space available. They have internet attached to it. It is in the internet and can be found with an IP address. So instead of putting our own server in the internet, we go to these web hosting providers and then we buy some space from them. Once you buy the space, you get that IP address and the space from the web hosting providers. Okay, and then you want to assign a domain name, that is the English name for your IP address. You go to something called as domain name providers, who basically sell a domain name. And once you buy the domain name, you have to do a configuration. You have to say, this is my domain name and this is my IP address. If someone is trying to access your domain name, that request is sent to the web hosting provider. So remember, there are two types of providers, web hosting providers and domain name providers. Web hosting providers sell space. They have unique IP addresses, so they sell space in their server. Domain name providers sell that English names that you can buy. It has to be unique in the internet and you can attach to that IP address. Okay, so let's look at an example who are providing the web hosting providers and also domain names. Okay, so let's look at the web hosting providers. So HostGator is one of the vendor or the provider in the market who provide web hosting, and they provide web hosting for $2.75 per month, and they have their own plan. Okay, so let's look at different plans that they have. You have dedicated hosting, means you get the full control of the PC. You have dedicated control, full root access and scalable resources. There's some differences in the performances here. Then they have the web hosting for WordPress. You want to install WordPress, they have special softwares to do that. Then they have a simple drag and drop where you don't get very much control on the server, but you get this softwares to create websites. Okay, so let's look at their plan of web hosting. You click on web hosting. So here are their plan. Okay, and many of them, all the plans come up with this unmetered bandwidth, means you have unlimited bandwidth, so you don't run out of the bandwidths of the internet. And what they are saying is single domain, unlimited domain, and unlimited domains means you can point n number of domain names to this one server. For Hatchling plan, you can have single domain. For baby plan you can have unlimited domains, and similarly for business you can have unlimited. But once you go to business plan, you get this dedicated IP. For hatchling and baby, you will definitely get an IP address, but that is shared with others. Okay, and when you go to business plan, you get this dedicated IP address. Okay, and you'll get the free access certificate, and you get many other components of it. The most important thing that you have to understand is they are selling space in the server. They have this server, massive server, and they are selling space in their servers. So you get the space, you get the IP address, some are shared, some are dedicated, and you pay the price to get those details. If you click on technical specs, right, you will see some of the details of that server, and they'll tell you what other offerings they are giving you. Like in terms of programming and database, they give you MySQL installed on that server. You get that cPanel to access, you get email feature, you get all this support and all those tools available. Okay, so they are actually selling you a space on the server with some software installed on it. Okay, similarly you can go to Bluehost. Bluehost also have web hostings. Okay, they have WordPress specially hosting, e-commerce hosting, and they get dedicated hosting as well. Dedicated hosting is one server, they give it to you, and you have the full control of that server. And when they talk about server, obviously they talk about cores, space, RAM, bandwidth, IP addresses. They're really talking about computer, right? They're talking about computer which is in the internet and have an public IP addresses. So first thing you have to do is you have to buy a space, right? You have to buy a space, and you have to buy a space in any of the servers. You can start small, like $2 per month, or you can go up to dedicated hosting where you get to have your own server, and you can get to choose what kind of server you want and even what OS you want, right? That is the first step. So these are the vendors. One is HostGator, another is Bluehost, and there's DigitalOcean as well. In DigitalOcean you create something called as droplets. Okay, let's look at what is the droplet. Let's look at Ubuntu. And to create the droplets, they give you a price. Let's say you want 1 CPU, 25 GB SSD disk, 1 terabyte of transfer, that's the bandwidth, 1 GB of RAM. You have to pay $5 per month. So they'll give you the server, and then you are on your own. You do install whatever you want to install on that server. So these are called as web hosting providers. They provide space in that server. They even provide you server access. They even let you choose what type of servers you want, and then you have to just pay the price. Okay, once you buy the space and the IP address, you need to have an unique English names, right? And where do you buy the English names? You buy that from a domain name provider. And if you go to godaddy.com, so godaddy.com is really very famous for selling domain names. So the first thing, when you go to their homepage, they'll ask you what is the domain name you're searching for. Okay, similarly, if you go to namecheap.com, they will help you find a domain name. Once you purchase a domain name, then you can go inside the configuration to configure a domain name with the IP address. Okay, so let's do a quick check of what is the domain name available or not. Let's say you want to buy yahoo.com, then they'll say yahoo.com is taken, you cannot have it. Okay, so domain names are unique. It's an English name that you're buying. You're not assigning it to a server first, right? You will buy this, and then once you have this server, they'll give an IP address. Then you do the linkage between this server and that server. That's a configuration altogether. But remember, on a high level, there are two different kind of people in the market. One is the web hosting provider, that is the HostGator, Bluehost, DigitalOcean. They are giving you the web server. They're giving you a server with a space in it, and then they have a unique IP address. There are another type of providers who provide you the domain name. They are selling the domain name so that you can assign this domain name to this IP addresses. So it's easy to see you have two different kind of providers in the market. One is really selling the web hosting, another is selling the domain name. So now that we have seen the web hosting providers and domain name providers, let's understand how the DNS works. Okay, so let's take a step back. Let's say Bob has purchased the web hosting, and also he has purchased the domain name, and he has assigned his domain name to his IP address. Well, remember this, when Jim types bob.com, the computer doesn't understand DNS name. The computer only understands IP addresses. The TCP/IP protocol, the rule says you need to have an unique IP address. The rule never talks about DNS. So there should be a way to convert your host name into an IP address, and that is done via something called as DNS servers. So in the internet, there will be so many DNS servers always syncing each other to tell that this, based on this DNS name, this is the IP address. So once you purchase from GoDaddy.com, they sync that detail. Like let's say you purchase yahoo.com, then the GoDaddy.com will sync those details of your DNS server to all the DNS servers in the internet. Okay, so remember, there is a DNS server in the internet which converts your host name, that is the domain name, to the IP address. Once you find the IP address, then that Bob computer can be uniquely identified in the internet. Then the TCP/IP protocol can help to connect and communicate the message to that particular system. Okay, so that's the role of the DNS server. So if you look at the internet as a whole, right, every computer has an IP address and every computer get to have an DNS name. Okay, and then there are DNS servers sitting in the internet. Whenever someone types the DNS, then that DNS is converted into an IP address first, and then the communication happens on that IP address. In the previous example, when you say ping yahoo.com, ping google.com, the yahoo.com and google.com are nothing but the English names, right? They are DNS names, and conversion of that DNS name into an IP address is done by the DNS server. So remember, in the internet there are DNS servers. The job of the DNS server is to convert the DNS name into an IP address, and once the conversion happens, then it's easy to find those servers in the internet. Alright, so let's do a definition of what is DNS. So DNS stands for domain name system. That's the full form of DNS. Well, DNS name can also be called as host name, and the main purpose is to easy to remember names that is assigned to an IP address of a computer in the internet. Okay, because it is hard to remember IP address, we buy this domain name, we assign the domain name to the IP address, and in the internet the DNS server take care of converting that domain name into an IP address. Okay, so DNS server basically helps to convert host name to IP address. You have to remember this concept, because once you buy the domain name, you need to know there are DNS servers, okay, which actually helps to convert the host names to IP address. And then you have to purchase the domain name, and once you purchase them, you have to do this setting by yourself. No one is going to do this for you, because no one knows what is your IP address. So once you buy the domain name, you have to map this IP address to the domain name. Okay, so understand this concept of how DNS work and what are the components of it, and what you have to do once you buy the domain name as well. So let's look at the problem that we have seen with Jim and Bob. So now Jim and Bob can identify themselves with the IP address, and also with the DNS. Now Bob can buy an DNS name, that is bob.com, and then he can match this bob.com with the IP address, and Jim can find Bob computer via the bob.com, that is nothing but the DNS name. So now we have solved the challenge of how Jim can really find the Bob computer, but there's one more challenge. Let's look at it. Well, the challenge is you can use TCP/IP protocol to transfer the data, any data, right? But you want to transfer a specific files, like the text files, pictures and videos. Then what protocol can help? TCP/IP is basically a transport protocol. What is mean by transport protocol? It's basically doesn't understand what you're transferring. It just transfers zeros and ones, right? It is just the purpose of TCP/IP is to find that computer via the IP address and transfer the data. It doesn't really care what you're transferring. Okay, but if you want to take a level up and then say, okay, I just want to transfer files, pictures and videos. These are nothing but the file formats, right? And you want to transfer this from Jim computer to Bob computer, or you want to pull those information from the Bob computer, where protocol can help. Okay, that can be done via the HTTP protocol. So let's understand what is HTTP in the next section. Hello and welcome to the lecture. So let's understand what is HTTP. So let's understand what protocol can help to transfer files, pictures and videos, because Bob want to send maybe the image of a phone to the Jim to show that this is how his phone looks like, and maybe Jim can fill up a form and then process his payment via transferring his data to the Bob. Okay, so there has to be communication between Jim and Bob via the specific formats, that is basically files, pictures, or videos, right? And what protocol use? We can use TCP/IP because TCP/IP isn't transport, it's an underlying protocol. The responsibility of TCP/IP is just to transfer the data irrespective of the format. Okay, so let's understand what is the protocol that we'll use. The protocol that we'll use is HTTP protocol, and HTTP stands for Hypertext Transfer Protocol. When I say hypertext, well, hypertext is nothing but your videos, pictures, music files, and normal CSV files. These are called as hypertext. So if you want to transfer hypertext between the computers, you have to use a protocol called as Hypertext Transfer Protocol. And HTTP is an application protocol, means it is abstraction. It is one layer on top of TCP/IP protocol, and that is protocol that is used to transfer data like images, video, files over the web. So remember, in the web, when two computers can find each other with an unique IP addresses, and then there is a connection between the two computers via the TCP/IP, there's one more protocol built on top of TCP/IP protocol called as HTTP protocol. And using this HTTP protocol, you can transfer these hypertext files. Okay, as I say, hypertext is nothing but the media files like images, videos, files, and you can transfer it via the HTTP. So when we talk about details of HTTP and web, you are more focusing on these kind of data like JSON file, XML file, video file, images file, because this protocol is built in such a way that it is able to handle and transfer this kind of files over the web. And remember that HTTP will depend on TCP/IP protocol to transfer the data. But how the data should be transferred, what kind of data, is basically handled with the HTTP. And obviously it is a protocol, so it has set of rules. How do you make a communication? How do you initiate the communication? What type of request that you have to send? All this been pre-coded into HTTP. So when Jim types bob.com onto the browser, he's basically using something called as HTTP protocol. Okay, and this HTTP protocol is responsible for communicating between the Bob's computer and transferring all the data from Bob's computer to the Jim computer. So let's do a quick definition of what is HTTP. HTTP stands for Hypertext Transfer Protocol. That's the definition of it, because HTTP purpose is to transfer the hypertext. That's why it's called as Hypertext Transfer Protocol. And HTTP protocol is used to transfer images, videos, files over the web. Obviously, HTTP uses TCP/IP protocol to transfer the data packets between system, and it is built on top of TCP/IP. So that's all about HTTP protocol. Let's understand how HTTP actually works in the internet. So we go details of how HTTP works and we'll understand the details of it. So what is the word protocol actually means? Protocol in general English means agreement, contract, arrangement, or deal. So in order to achieve something, we get to an agreement, we agree a deal, or we sign a contract, or we get to an arrangement. That's a real life scenario. In a communication scenario where two people want to communicate, they can make an arrangement, they can make an agreement, they can make a deal, or they can make a contract to talk in a language they both understand. Let's imagine you go to a new country. Then you will make sure you speak in English. Why? Because it is a protocol that you think everyone will understand. Same like body language. It's a protocol that many people will understand. So you use them. You can communicate only when you have protocol or a common understanding with the other person. Means both agree to a protocol. You can even say this: protocol helps to communicate. I'll give you one more definition. An agreement on a common language to communicate can be defined as a protocol. So remember this understanding of protocol. It is a contract to communicate. Let me give you another simple definition. Protocol is nothing but a set of rules to communicate. We can even call this protocol as communication protocol to make sense in the context of communication. Yes, I know, I repeated the same definition in different ways to make sure you can understand it. And I hope you understand the definition of word protocol. If not, then go back and listen again and make sure the definitions stick to your vocabulary. Here onwards, I will use the word protocol, which actually means are some kind of rules used to communicate. That will be my understanding. Next, let's define HTTP with the use of the new word that we just learned, that is protocol. Before we jump into HTTP, I want to bring the context of understanding to system level. We learned protocol as in general, right? Now let me bring you the same definition when two systems want to communicate. If human can communicate via protocol, then why not computers? Yes, computer can use a protocol to communicate. Let's say two systems want to communicate, then they have to agree on a protocol so that when they talk to each other, they understand what they are interpreting. And if the protocol is changed, then they have to re-agree on what is the new protocol that they want to communicate on. Let's take this concept further. If you just look around yourself, we use protocol everywhere. When we connect to our home Wi-Fi, that's a Wi-Fi protocol. When we transfer a file to a server or download a file from a server, we use an FTP protocol. When we send emails, that is transferred via an email protocol. Everything that we do has a protocol, and we cannot change the protocol. Like we cannot send email with an FTP protocol, or we cannot access Wi-Fi with an email protocol. So every protocol has a set of rules, and with that rule you can only do a specific job. You must use the right protocol to communicate with the right device. Means you should talk in the device language in order to communicate with the device. If that device speaks Wi-Fi, then use that Wi-Fi protocol. If that FTP server speaks FTP protocol, then speaks in FTP protocol. That's basically how humans interact, right? If you and me understand a native language, we might be talking in that language. I hope you're getting the idea. The point I'm then trying to make is we use specific protocol to communicate to specific devices. Let me now define what is HTTP with the context I just explained to you. HTTP stands for Hypertext Transport Protocol. So let's look at the definition one by one. What is hypertext? Hypertext in general English means text that is displayed on your computer screen. And transport means the text that is being transferred. Protocol means, I bet you know what protocol is. Well, I repeated it many times. It is a rule to communicate. So let's look at things together. HTTP is nothing but a protocol that is used in the web to transfer that hypertext onto your computer or transfer over between the machines. Let me give you a simple definition. HTTP is a protocol used to communicate in web by machines. So don't assume HTTP can do everything between the two systems. HTTP typically used to transfer text between the machines on the web. So web is a very big word there. Yes, web is a keyword that we need to really understand. Then you can understand what is HTTP stands for. Web generally means it is an interlinked systems or network of networks. You can imagine like large number of systems connected with a one wire, and many systems can exchange information, and also every system connected in that network has a unique name to it. And using the web, using that network of networks, we can access any data that is available in any of the systems. It could be document, images, audio file, video file, any files. So let me again walk you through what is the context here. Web basically means there are large number of computers connected together with a single wire, and then each system has many files in it. So typically what you're trying to do here in the web. So typically you're trying to get some data from the server residing in the web. And what actually helps you to get the data? HTTP is a protocol that helps you to fetch that data from the server in the web. Again, it has the rules that we need to follow, and this course is all about learning those rules. In the next sections, I'm going to teach you what are those rules that HTTP follows to fetch the data from the servers. And all the things that you do with HTTP, you're trying to fetch the data or you're trying to send some command to the server within that web. to do something with the data because it is an hypertext, right? So let me give you a simple definition to remember. And don't forget this definition because this definition will explain what is HTTP. HTTP is a protocol used to communicate in web by machines. And now you know what web means. Let me show you where do you generally use HTTP. If you open your browser, and generally you might have typed podcast.com, and before that podcast.com there's something called as protocol, and that protocol you might see https:// we are talking about HTTP, then what that S stands for? Well, S stands for secure, right? And podcast is a secured site. So that HTTPS or HTTP generally indicates what protocol you're using to access the podcast.com website. So podcast.com is a server sitting somewhere in the web, and you're using a browser to access the site, and all the thing that you're trying to do is saying to HTTP, that's our friend, HTTP, can you go and connect to this podcast.com server and fetch the site for me? And that's how the protocol helps us to communicate in the web and exchange the message between your machine and the server in the web. In the web, all the servers are sitting and connected. All the servers hold the hypertext. So all you have to do is to apply the universal law, and that is ask and it is given. Well, HTTP works similar way. You need to ask, or your system need to ask to get that hypertext, and all we use is one of the example is the browser. You ask via a browser to show something. That's how the request is fulfilled. And in the web of servers, we need to go and keep asking so that the server will keep providing you with the details you ask. And it's not something new, right? We do it every day. You go to Google search engine, you ask, and then whenever you ask, the Google search engine will execute something and fetch the data for you. If you're looking at the diagram, there are two roles. That is a new jargon there. Understand this jargon because I'm going to follow this jargon throughout this course. The role on the left hand side is called requester, and the role on the right hand side is called provider. So requester is something who request and provider is something who provide. So requester needs to ask the provider, or the requester need to request and the provider has to provide something. Easy to remember this concept, right? Requester will request and provider will respond. Don't forget this diagram and the theory that we just discussed. This is the one of the more important topic or concept behind HTTP. Ask and it is given. If you don't ask, then it's not given. No request means no response. Let's make this definition go one step ahead, and then we correlate with the things we do in our daily life. By now, you should be very clear how HTTP helps to send a request and get the response. Let me bring back another jargon here, that's a client-server technology. In the client-server concept, client is a requester, server is a provider. Client makes a request and server will respond. We do this every day, right? We type the URL in the browser, that is your client. And then once the request is sent over to server, the server will respond back to your client. And what is helping us to communicate between client and server? When you do it over web and you want to access hypertext, it is the HTTP protocol that will help to send your request to the server and receive the response from the server to your client. And thanks to Berners-Lee, the gentleman who has invented this concept and make it available for us. Next, let's look at how HTTP communicate or what's inside this protocol. So we understand there is some kind of request and response to happen in order for us to communicate in web. And HTTP is our best friend who helps us to do that work for us. Let me show you the demo on how real time this works. Obviously you won't understand everything shown in the demo because we did not learn how HTTP talks and what is its language. But I want to make you understand that there is a request and a response. Let's look at it. So let's look at how HTTP is used to send a request and get a response. So I will visit a site, and now I will press F12. This will bring up the console, and you have to go to the network tab, click on the network tab, and then you will see some information here, right? First thing we'll notice what is a protocol. Okay, so if you look at the URL, you're actually using an HTTPS URL, right? As I told you, S stands for secure, right? So HTTPS is trying to help us to go to this server and trying to fetch all these files for us. Okay, let's look one more time. So HTTP protocol will go and connect to the system, download the files. So all the files that is available on pocast.com server will be downloaded by this client. So this browser is a client, or this browser is a requester, and pocast.com is a provider, or a pocast.com is a server. Okay, so let's look at the pocast.com request. So when you double click this, I just double click this and I see this history. Okay, so let's review this. So let's say I press one more time. You can go to this tab, then you can see different tabs here: header, preview, response, cookies, and timing. Let's look at the headers. So there is a request header and a response header. So we send a request, we get a response. So that is the definition that we have learned in terms of HTTP. So let's look at request. You might not be able to understand everything that is being sent over to the server, but I want to bring you the attention that it's saying I'm talking to you with a HTTP 1.1, means I'm using 1.1 version of HTTP to communicate to you. And where should the request should go? The request should go to pocast.com server. Now let's look at the response. You have to click the view source. The response says, okay, I understand that even I sent you a response with 1.1 version, and it's okay, it's nice. I mean, I acknowledge your request and I am sending you the data. And if it's unable to send the data, maybe you get a separate error. That was a 403 maybe when you don't have access to the server, right? So this is how the request and response works. Let's look back into other definitions, and then we come back here and again relook into these definitions. In the hands-on, we have seen how the browser sends the request to the server and how the server responds with the HTTP response. I'm just trying to show you what is the structure looks like for an HTTP request and a response. The response or a request will look something like this. It will have a message header, then an empty line, and then it will have a message body. When you're sending a request without any data, then the message body is empty. And well, when a HTTP send a response to you, then the message body has the data. And what details are available in the message header? Let's look into it. Let me explain about the content type. Content type means when a request has been sent from our browser to a server and from server to our browser, we are exchanging some data. Content type is generally a type of the data that has been exchanged between the two servers, right? So in a request header, if you're seeing the screen, the request header generally says I accept this kind of data. Means this client, my browser, is telling to server that I can accept text or an HTML based output. I can accept an HTML and XML based output, and I can accept XML or an image, or actually it accepts everything, right? is saying I have the capability to accept all these things, and that's basically a content type. So request headers is basically a header sent by my browser to the server stating what I can accept. And when the response is being sent from the server will tell us what is being sent over. So the response use the field called content type, and then it's actually mentioning text.html, which saying I have sent you the HTML files. And HTML is a generic content type, can include CSS, JS, JavaScripts, can include your HTML files, all those things. So this is a very key concept when you deal with request and response. So let's say you're writing a program, let's say you're sending a video file, right? And then you want to send the content type to a type video. So you can write a program. In the program, you generally set the request header to say I'm not sending a text, I'm sending a video. And then when the server reads it, it's a video, it might use a different method to accept the file, because it expects when it's a video, actually the content size will be higher. So it might change its mechanism to read the data. And in the similar manner, when server try to send the data to Chrome using the content type saying it's a video, the Chrome can change its behavior to say, oh, this could be a large file, so I better download this file, or better I show them right away, right? So content type is really an important topic in HTTP. Let me show you another property of the request that is called as request methods. If you look at the request headers, you can see the first is a general, right? General actually say request method is get, right? So it's actually trying to get something, right? And if you look at the request header parsed, you can see it's also a get method. So request method generally are many types. Request types are used by the requester to tell to provider what it want to do. The first request type is get, that's what we see. Get request type is used by the requester to tell to provider that it want to fetch something from a server. It's like downloading. The header request method is used by the requester to get the header information from the provider. The post request method is used by the requester to post some data to the server. Similarly, put is to store the data at the provider. Delete is to delete the data at the provider. Trace is to request a trace from a provider. Option is sent by the requester to request what options does provider support. And connect generally is used in a proxy scenario wherein you're trying to make an SSL connection. And there are other extension methods. Actually, there are many request methods. The most important ones are get, post, put, delete. So these are the 4 options you will use mostly in your interface development. Let's look at status response code, which actually means when a request is being sent to a server, how the server has processed that request and what happened at the server. Let's take an example. When the request has been sent to a server, the server could be crashed. The server don't know what to do with the request. The server could not find the resource that requester is asking, or the server is just crashed. So in those scenarios, there should be some responses sent back to the requester to tell him what happened, right? And that is the response status code. So if you look at the property here, you see a number called 200, and server is not gonna send a big text in a description stating what happened. It uses this shortcode notation to identify or to tell to requester to say this is what happened at the server. And 200 generally indicates it's a success. And if you look at the response header, you can find that 200, which means it's okay, means everything is success. Let's look at all the response code that is been sent over by the provider to the requester. It's a response code, so it's sent as a response by the provider. And you can find this response code as I showed you previously in the Explorer. Previously you have seen the status code 200 as an OK. So I'm just going to list out all the different codes that is been sent from a provider. If the code starts with 1, it actually means the request is received and server is continuing the process. Why server want to send 100 or 101 information back to requester. So it basically could be a technical act to say, I received your message, but I'm still processing it. The 200 generally say, okay, I understood your request and this is the output, and everything has been served. 3 means it's a redirectional, wherein a further action must be taken in order to complete the request. When you see a status code starting with 4, means it is an error. All the status codes with 400, 401, 403 are error status codes, which could be result into a bad syntax, or the request is not been understood, or the resource is still not there on the provider and then requester is requesting for it. And anything that starts with 500 is basically a server error. It's not the issue with the requester. Requester might ask anything that's available on the server, but server could not provide it because of the server have some internal issue. That's when server will provide a status code starting with 5, which means server failed to serve the request. Port you can think like a small holes to the computer, through which server accepts the data and sends the data. Server provides number representation to each of these ports. You are using HTTP request or response, it will be 80 port. If you are using an HTTPS based request and response, then it will be 443 ports. If you have to imagine server as a bottle of water. Then port are the small holes that you drill through it, through which you can actually extract the water. Similarly, if server accepts HTTP, it will open 80 port. If it accepts secured connection, that is HTTPS connection, it will open a 443 port on its server. So remember, these numbers, they are fixed, they are standards, but it can be changed. So whenever someone say I'm connected to an 80 port or can you connect to an 80 port, they are referring to a standard port. And HTTPS generally is a 443. When it's secured, actually the data is encrypted. Even at the client side, even at your system side, you will be sending all your HTTP data via that same port. It's like client will come to a server water bottle and put a glass on the port 80 and request for water, then server will respond with the water. In web, when you type the URL in the browser, your system based on HTTP 480 or HTTPS for 443 will make a connection to the server's IP to that port to request the data. This is visible in the logs on which port the server is responding the data. And any system can change this default port to any other number they want. It could be like 8080 or 8181. I'm just giving you a representation, but the numbers could be anything. How to identify the port? So every server has an IP address, right? So we define a port after the IP address. We put a IP address, colon, and the port. And that port is not visible when you typed pocast.com because you're not referring to that IP. You're referring to an host name. Host name are generally a virtual name given to an IP. So instead of typing that big numbers, you can just type the host name. And in the background with the protocol, let's say I'm using a protocol called HTTPS, I'm automatically routed to 443 port on that specific server. And let's say you are using a PI or a PO server, you will always use a custom port. You might not be using an IP address and imagine the HTTPS will connect to 443. That's not going to happen. The PO or PI servers will actually have a separate port. So every time you access that URL, you will use the host name or the IP colon the port name to access that port and saying that using this port, try to make a connection and send the data. Well, in case of FTP protocol, it is 21 or 22. Of course, they are standard port, but that can be customized to any number. So remember, from a HTTP context point of view, HTTP is 80 and HTTPS is 443. That's a lot of information being shared. Let me summarize and redefine or just recap what we have learned. So please concentrate. The first, we define protocol. Protocols are a set of rules to communicate. Then we define HTTP. HTTP is protocol used to communicate in web by machines. Then we define two roles. One is requester and another is provider, wherein requester will ask or request, provider will give or response. What's the usage of the HTTP? HTTP protocol helps to establish communication between our web browser and destination server. HTTP request and response will follow a common version, and HTTP request will inform server which one to use. HTTP request format has message header and message body separated with an empty line. Same for HTTP response. HTTP request and response will communicate about the content type they are exchanging. Request will say what it will accept, and provider will say what type of content is sent in the response. And ports are used to exchange the message. HTTP use port 80, HTTPS use port 443, and server or client use port to send data and receive data. HTTP request header will have type of request to indicate what it is trying to do, like requesting something, posting something, want to delete or want to store, etc. The commands used are get, post, delete and put. For more info, refer to the slides. Server send response status back to client indicating in the number format. If the server status start with 1, it actually means informational, 2 means success, status starts with 3, it means redirect, 4 means client error, 5 means server error. Again, refer to the complete list from the slide. Hello and welcome to the lecture. Let's understand what is client server technology. So first let's understand what is these words called as client side and the server side. You have to understand these words because we're going to use this language in further sections. We're going to talk about client side, server side, then you should understand what I am talking about. So before that, let's understand what is client side and what is server side. And imagine the situation wherein Jim is basically the buyer and Bob is the seller, and Jim is trying to access Bob's computer via the host name. And then Bob actually have a server where all the files has been stored, all those images, videos and all these files has been stored, and the Jim want to send a request to Bob saying that I want to buy a phone. So in this context, Jim logs in into the web browser, he types bob.com, he send the request to buy the phone. Okay, then the Bob computer accept that request and say, okay, let me send you a response saying that okay, I have a phone available and you can buy for this price. And then the transaction between Jim and Bob happens, and Jim can agree to whatever images he's been showing, and then he can agree to pay the price via the payment method that Bob is offering. And once he pays it, then Bob will transfer that phone to Jim. Okay, so that's basically in this transaction, right? Jim is client side, he is initiating the request. Okay, he is client side, he is the one who is sending the request, and Bob is server side who is hosting the details and who is responsible is to send the response. So remember, the client side is where the Jim access the browser and browser is sending a request to the Bob's computer. So Jim becomes the client side and the Bob's computer who's hosting all the files send the response based on the request sent to the Bob. Okay, and Bob is called as server side. There's another name given to him. The client side can also called as requester. Really, he's a requester because he is requesting the details from Bob, right? He is the one logging onto the computer and typing bob.com. So he's a requester, he is client side, and the one that is providing the response is called as provider. Okay, we'll be using this terminology to understand further concepts. We'll be using client side, server side, requester and provider. In this client server technology, there is a requester and there is a provider, and the requester is always requesting the information with the provider, and provider is basically a server sitting in the internet with some files in it, right? And requester is always requesting that information to the provider, and the provider, once it gets those requests, it serves the request by providing a response back to the requester. And all this communication of request and response happening over the protocol called as HTTP protocol. So whenever you see HTTP protocol, so remember that definition. Whenever there is an HTTP protocol, requester is requesting the information and providing is sending that response to the requester. Okay, and all this is happening via an HTTP protocol, which is nothing but an application protocol that is used to transfer data in the web, and that data is nothing but the hypertext. Okay, and we have looked at what is client side. The one who is requesting is called as client side, and one who is providing all those information that is sitting in that server is called as server side. Well, there could be multiple clients and single server. Well, multiple clients like your mobile phone, computer, laptop, all these are trying to access the server and requesting to fetch those details, and server is just accepting those requests and sending the response with all those details back to these clients. Okay, and all this communication happens via the HTTP protocol. Okay, so that's how the client server technology works. Server holds all the information and it is a powerful machine. Most of the times your servers are powerful because server has to handle all the requests from the client. Okay, so it holds all the information and the job of server is to get the request and send a response. Okay, many clients initiate the request to the server to fetch the data, and then server accepts the request and send the data as a response to that client. Okay, and then client server technology is also called as request response pattern. So if you're hearing request response pattern for the first time, it is embedded in the concept of client server technology. If you understand client server technology, it is nothing but request and response pattern. Client initiate the request and server give the response back to the client. Okay, that's nothing but called as client server technology. So that's all for this lecture, and I'll see you in the next one. Welcome to the lecture on how website works. So let's understand what are the components that makes up a website. Well, we have seen the request and response pattern, that is nothing but the client server technology. The client side, basically a browser, someone will initiate the request, someone will type like phptraining.com. The request is sent to the server and server will have some files on it, and once it gets the request, it sends a response back to the browser. And whatever the request is requested for, whatever the resources that they have on the server is requested, will be sent from server to the client. Okay, that's nothing but the client server technologies. So let's understand what are the components sitting behind this phptraining.com on the server. On the phptraining.com server, there is something called as web server. Okay, there are different types of web server. We're going to look into types of the web servers that we have. But understand there is a web server who is listening to these requests. Okay, this server is basically saying, okay, this is the request, this is the response, this is the request, this is the response. That's the job of the web server. The web server is always in the listening mode. It is listening for requests, and whatever the request has been sent to him, it will try to execute that. Like if the request is to get a file, then it will execute that command to get the file and send that response via the same web server. And if the request is to execute some language, let's say you have a PHP program, Python program sitting somewhere in the server, and the request is to execute that program, then it will execute that program onto the server, and whatever response comes from that program sent again via the same web server. And your web server typically have database as well. If you're storing the database and you're requesting to fetch the details, then the code that you wrote at your server side will connect to the database, fetch the data, and then it will send back to the web server. Then the web server will send the data back to this client. Okay, similarly, any request that has been done to fetch any of these static files, hypertext files or media files like images, pictures, is again taken care by the web server. So in this context, so the web hosting comes in picture when you want to have these details. When you have this web server, you want to have some language support, you want to have database files and everything, you buy this from web hosting. Okay, and if you want to have a domain name, that is phptraining.com, you get it from the domain name providers, that is nothing but the GoDaddy and the Namecheap. The web hosting is provided by the HostGator, Bluehost, DigitalOcean, where you get the server and some of the softwares installed on it. Domain name you buy from GoDaddy and the Namecheap, where they sell the domain name, and then you map the domain name with the IP address. Okay, so let's take an example and I'll show you how these things work in real time. So let's do an example and understand how these things work. So this is a server that is sitting in the internet and I have a public IP address for it. Okay, and on this server I'm running a web server called as Tomcat, Apache Tomcat, and it is in the listening mode. You see it's blinking, it's listening for request. Okay, the server has been started up. Well, this server is in listening mode. It is listening for request, and whenever the request comes, it will serve that request. So what I'm going to do is I'm going to create a folder. There's a folder called PHP training, and I'm placing an image, I'm placing a video file, then there is something called as an HTML file. Consider this as a file, and what I want to do is I want to fetch these files from the server onto my browser, right? And remember the role of web server. So all the request goes to this web server. This web server will locate the files under its own web apps folder. Okay, it's under Tomcat web apps in the PHP training. So when we try to access, we will provide this name PHP training and we'll say I want to access these files. Then we'll see from the browser how this Tomcat will get the request and send the response to us, and how the HTTP protocol works in the real time. Okay, we have learned about the client server technology, request and response. We talked about HTTP. All these things we're going to see in the real time. And the challenge that we are trying to understand here is the server is having all these files. Okay, how a client could make a request and fetch all these details from the server. Okay, well, this is nothing called as hypertext, the text file, image file, video file, and then we'll try to initiate a request to fetch those details. Okay, so I'm going to minimize this and I'm going to open my browser now. Okay, well, this is the IP address where my Tomcat is running and I have my files, and we have seen the phptraining.com. that is nothing but the folder there, and inside the folder there is a file called index.html. so I'm making a request to my server saying I want to access this index.html file. So when I click enter, so you see the image is been fetched, the video has been fetched. I can play the video, right? I can play the video, means the video is fetched to my client browser, and there is some text that has been displayed onto my browser. Okay, so what is happening in the background? How these things all work together? You are sending a request from your browser to the server, and server has a public IP address. Remember, this has to be accessible from anywhere from the internet, and this is unique. And using this unique IP address, I have a web server running on that server, and on that web server I created a folder called PHP training and I have some files on it. So I'm trying to say to this server, to the web server, you have a folder called PHP training, can you fetch me this file? And this file actually embeds all those images and videos, and using which it is trying to print those onto my browser. Okay, so let's quickly jump back to our server again. So this is our web server and we have this dog image. Let me open that up, and then we have this video file. These are called as resources. These are called as the hypertext. Okay, let's go back to our browser. This time we will see HTTP protocol in action. So for that, right click on your browser, go to inspect, or you can say Ctrl+Shift+I. You will come to this window. You can toggle that dock onto your bottom. Then you go to something called as network tab. Okay, so now we will see what is the request that has been sent and what is the response that we're gonna get. Okay, for that you have to refresh the page. So when you refresh the page and when you open up your network tab, you should able to see the files here. Okay, this browser has sent a request to the server and server has responded with these resources to it. Okay, this is request and response in real time. Right, if you open or click any of this, you go to headers, you will see there is a request URL. So you are sending a request to this URL and there is a response, and response is nothing but your HTML code, that is nothing but some files. Okay, text files, and you can see the files here, right? You get the image, you got your video, you got your files, and this all fetched from the server. Let's do one more time refresh, and refresh basically getting all these files. It is telling you how much seconds it has taken, milliseconds it has taken to fetch those resources from the server. Okay, so this is how a website works, right? A website is hosted onto a server which has an public IP address, and then you create a folder on it, and then you create some files on it, and using a browser you try to access these files, and this file is basically linking up other resources on the server. So once you request this URL, then the server, that is nothing but the Tomcat server, will get the request and it will respond with all the files that has been requested and send back to the browser. Okay, that's how a website works. So for that website, you see here I don't have a domain name for it. I can still access my server with the IP address. As I told you, TCP/IP does not require a host name, it works on the IP address. And this is how the HTTP works. This is not TCP/IP protocol, this is an HTTP protocol. So this is an HTTP protocol, hypertext transfer protocol, using which you can send a request to a server and fetch all the hypertext from the server back to your client side. Well, that's all about how a website works, and I'll see you in the next one. Hello and welcome to the lecture. Let's understand type of languages that we have. So we have three different types of languages. First is called as programming languages, scripting languages, and markup languages. You have to understand the difference between them because they have written and implemented differently. And the purpose of each of this language is to solve a different challenges. Okay, so you have to understand this, what you're trying to learn, right? When you're trying to learn a language, whether it is a programming language, scripting language, or a markup language. So the examples of a programming language are like C, C++, and Java. The most important job of a programming language is to interact with the machine. Programs like C, C++, and Java are famous examples of how they can really interact with this machine. So they have this machine level language converted, using which they can really interact with the hardware as well. Okay, that's the power of the programming language. So when you're learning a programming language, you are mostly learning how do you interact with your machines, right? And if you want to write machine level programming, this kind of programming languages will help you do that. Let's look at scripting language. So PHP, JavaScript, Python, and Ruby are scripting language. They are built on top of the programming languages. Okay, they are not the underlying languages. They use like C, C++ or Java or other programming language, and they are built on top of it to solve a specific challenge. Well, PHP is a scripting language that runs on the server. If you want to run a program on the server side, you write PHP. If you want to run a program on the client side, you do JavaScript. Again, Ruby runs on the server side. Python can also be written on the server side. And also Ruby and Python can do many more than just running on the server side. You can write desktop applications as well. But remember that scripting language is actually built on top of any other programming languages. They use some internal libraries and they are built on top of it. So whenever you're working with scripting language, you will find it is easier compared with the programming language because they implement all the complex logic in the behind, and then they give you very easy implementation to write those programs. That's why scripting languages get famous, right? JavaScript, Python, PHP, Ruby, they're all very famous compared to C, C++, because all the complex logic is already pre-written in these languages. And when you try to use them, you're not implementing those complex logic, rather you're using those libraries which has implemented all those complex logic into it. Okay, that's why they are very famous. The other type of language is called as markup language. HTML and XML is markup language. HTML has a different purpose. HTML is used in web to link the resources. We're going to learn about what is HTML and all those things. But remember, HTML and XML are called as markup language because the way they write it, they mark it up all the details inside the file. And when they mark it, they say what they are marking up. They are marking up to link a resource. They are marking up to display a content, or they are marking up to link another file into the server. For this lecture, understand there are three types of languages: programming languages, scripting languages, and markup languages. And you have to understand the differences between this three of it. Well, programming languages are mostly uses compilers. So we're going to look at what is compiler and interpreter next. But understand, programming languages uses compiler to compile the code, and scripting languages are interpreter. They don't need to compile it, they run as it is. So we're going to see an example how this works in the real time. And the next section will be to understand compiler and interpreter. Okay, so that's all for this lecture of different types of languages that we have. Let's look at compiler versus the interpreter. Hello and welcome to the lecture. Let's understand what is the difference between compiler versus interpreter. So we have looked at different languages: programming language, scripting language, and markup language. And we have also discussed programming language uses compiler like C, C++, and Java, and scripting language use interpreter like PHP language, JavaScript, Python, and Ruby. So what is the real difference between compiler and an interpreter? Let's understand this. Well, in the compiler based languages, you write your code, then you compile your code. And once you compile the code, you get another machine level code which you basically execute it. Okay, So there is this two part that you have to do. Whenever you write a code, you have to compile it and you have to run the compiled code. That's the programming languages like C, C++, and Java, where you write the code but you cannot execute that code. You have to compile it first. Then once you compile, you get something called as machine level code, and then you execute that machine level code. Okay, so let's look at an example. Let's understand how to compile a Java program. Okay, so I have this Java program. Let's open this up, open with Notepad. Okay, very simple Java program to print hello world, right? But you cannot execute this code. Okay, you have to compile this. When you compile, you get something called as machine level code, and then you execute that code. So let's run this program. So before you run this program in the programming languages, you have to compile this. When you compile, you will get something called as machine level language. So when you compile, observe there's a file create, and you can only run that file. Okay, so let's compile the program. And when you compile the program, it will create something called as class file. So let's open this file. Okay, you cannot understand this program, right? Because this is machine level language. Okay, so let's run this. Okay, so you're able to print it now. So this is basically a compiler. You compile your code, then the file is created, compiled file is created, which is executed. Then you execute the compiled code, which is understood by your machine. So in programming languages, you have to compile the program. That is the first step. And then you have to run the compiled code. Okay, and the compiled code is not really in English. It will be in the machine language. Okay, and that's understood by the Java only. And then Java can run the compiled code, but it cannot execute the Java program, right? It cannot understand what is this English program that you have written. You have to compile that first, right? Once you compile, then only you can run that file. Okay, there's a two-step process in compiler. Okay, let's understand interpreter. So let's understand what is interpreter. So I have PHP basically is a scripting language, and it is an interpreter. So if you open any PHP file, okay, it has hello world. In order to execute PHP, you don't have to compile this. So if you go to this folder, okay, you have 1.php. You don't have to compile it first, but you can really execute as it is. You can see I did not compile it. There's no compiled code here as well. Okay, this is called as interpreter, where it is in interpreter you don't have to compile it. It interprets as it is running the file. Okay, so that's the difference between compiler and an interpreter. Well, that's the difference between a compiler, wherein you write the program, compile it and run it. In interpreter, you don't have to compile it. You just write it and then run it. And PHP is a scripting language that use interpreter. Java is a programming language which use compiler. Okay, so that's the difference between compiler and interpreter, and I'll see you in the next one.